Welcome to DevOps for Web Developers by Mitesh Soni, a video course by Pact Publishing. I am Adam Stewart, and I will be Mitesh's voice for this course. Mitesh Soni has 8 years of experience in managing software for GNU Linux and other Unix-like operating systems in production environment. He started working as a professional with DevOps from 2013 and has worked on several live projects related to DevOps. Okay, so let's now talk about DevOps for web developers. This course shows you how to accelerate web development with DevOps. It starts by introducing you to the culture and collaboration that needs to be promoted in order to use DevOps within your organization. You will learn why it is essential to build and deploy modern apps efficiently when embracing the DevOps methodology. You will learn to use GitHub to push code and commit the changes using Git. Moving on, you'll understand the basics of configuration management and the architecture of DevOps. You'll see how to take care of deploying the code into our new shiny servers. Then, we'll explore monitoring and various solutions to the range of problems we might face. Finally, you'll be able to develop, deploy, manage, and automate your complete web application on a cloud service. Now, let's look at our course. We'll start from scratch, providing insights into DevOps movement, challenges for developers team, challenges for operations team, challenges faced by organizations, waterfall and agile model, importance of collaboration, cloud computing, reasons to go for DevOps, benefits of DevOps, DevOps lifecycle, build automation, continuous integration and its best practices, configuration management, continuous delivery and continuous deployment and its best practices, continuous monitoring, and continuous feedback. It also covers an overview of code repositories, Maven, Jenkins 2.0, Chef, AWS, Microsoft Azure, Docker, Nagios, Hygeia, DevOps dashboard, overview of sample Java EE application. The next section describes in detail how Jenkins plays an important role in continuous integration. It covers how to prepare a runtime environment for application lifecycle management and configure it with Jenkins. It manages all the aspects of running a build to create a distribution file or web application archive WAR file for deployment by integrating with a source code repository, such as SVN or Git, for a sample Java EE application. You will learn how to install and configure Jenkins, and you'll be able to get end-to-end experience in build job creation and configuration, static code analysis, notifications, Jenkins plugins, and so on, as well as details on what exactly the sample application is all about. Later, we will describe in detail how to create the pipelines of different jobs for a sample Java Enterprise Edition, Java EE application. It will also cover the deployment of an application to a local web or application server and the configuration of a build pipeline for the life cycle of continuous integration. This way, Jenkins users can model application delivery pipelines as the code. Once we make it into code, we can store in a code repository and it can be managed in a better way. An important benefit is collaboration. As it can be stored in version control, different teams can reuse it for different operations based on the environment. After that, we will describe in detail the configuration management tool Chef, the installation of its components and alternatives, and the configuration of components and conversions of a node for preparing a runtime environment for Java EE application using cookbooks. However, writing a cookbook and a detailed discussion of Chef components is out of the scope of this section, as it will take up too much space. Now we will move on to describe container technology in detail and how it is different from virtual machines by comparing the benefits of both. It will give you an overview of Docker and its installation and configuration details. It will also cover how to create CentOS containers for application deployment. We will also cover Docker Hub and the basic architecture of Docker. We will see how to use the Tomcat image available on Docker Hub and create a sample image with a Java and Tomcat installation and a Docker file. Now we will describe in detail how to install Knife plugins used to manage cloud resources using Chef. It will cover creating instances in AWS and Azure using the Knife EC2 and Knife Azure plugins. It will also cover how Chef is used to manage Docker containers. The next section will cover prerequisites to deploy application on remote server, use Tomcat Manager app, deploying application in Tomcat Docker containers, deploying application in AWS Elastic Beanstalk, and deploying application in Microsoft Azure Web Apps. In the further section, we will provide overview of monitoring, Nagios monitoring tool and quick start on it, installation of Nagios, configuring monitoring of AWS EC2 instance, AWS Elastic Beanstalk monitoring, Microsoft Azure Web App Service monitoring, Microsoft Azure Application Insight, and monitoring web application and Tomcat server with New Relic. Finally, we will describe in detail how to orchestrate different build jobs for continuous integration, configuration management, continuous delivery, and so on. It will cover how the build pipeline plugin and pipeline feature of Jenkins 2.0 can be used to orchestrate an end-to-end automation process for application deployment. This video is a step-by-step practical tutorial that shows you how to harness the DevOps methodology and DevOps tools in a practical way to efficiently manage and automate the development and deployment of a web application onto a cloud service. This course is for web developers and IT teams who are new to the DevOps methodology and want to use DevOps tools to harness its full potential. It is also ideal for those who would like to learn about DevOps-orientated workflows and how they can be applied to the development of web applications. Some prior exposure to the software delivery lifecycle would be helpful. So, what are we waiting for? Let's begin this journey together, and I hope you enjoy the ride. Hello, welcome to the first section, Getting Started. DevOps, Concepts, Tools and Technologies. DevOps is not a tool or technology, it is an approach or culture that makes things better. This section describes in detail how DevOps solves different problems of the traditional application delivery cycle. It also describes how it can be used to make development and operations teams efficient and effective in order to make time to market faster by improving culture. It also explains key concepts essential for evolving DevOps culture. You will learn about the DevOps culture, its life cycle in key concepts, and tools, technologies, and platforms used for automating different aspects of application lifecycle management. In this section, we will cover the following topics: understanding the DevOps movement, the DevOps lifecycle. It's all about continuous integration, configuration management, continuous delivery or continuous deployment, continuous monitoring, continuous feedback, tools and technologies, overview of a sample Java EE application. Now we will see the first video of the first section, understanding the DevOps movement. Let's try to understand what DevOps is. Is it a real technical word? No, because DevOps is not just about technical stuff. It is also neither simply a technology nor an innovation. In simple terms, DevOps is a blend of complex terminologies. It can be considered as a concept, culture, development, and operational philosophy, or a movement. To understand DevOps, let's revisit the old days of any IT organization. Consider there are multiple environments where an application is deployed. We will see some sequence of events takes place when any new feature is implemented or bug fixed. 1. The development team writes code to implement a new feature or fix a bug. This new code is deployed to the development environment and generally tested by the development team. 2. The new code is deployed to the QA environment, where it is verified by the testing team. 3. The code is then provided to the operations team for deploying it to the production environment. 4. The operations team is responsible for managing and maintaining the code. Let's list the possible issues in this approach. The transition of the current application build from the development environment to the production environment takes weeks or months. Priorities of the development team, QA team, and IT operations team are different in an organization, and effective and efficient coordination becomes a necessity for smooth operations. The development team is focused on the latest development release, while the operations team cares about the stability of the production environment. The development and operations teams are not aware of each other's work and work culture. Both teams work in different types of environments. There is a possibility that the development team has resource constraints and they therefore use a different kind of configuration. It may work on the local host or in the dev environment. The operations team works on production resources, and there will, therefore, be a huge gap in the configuration and deployment environment. It may not work where it needs to run, in the production environment. Assumptions are key in such a scenario, and it is improbable that both teams will work under the same set of assumptions. There is manual work involved in setting up the runtime environment and configuration and deployment activities. The biggest issue with the manual application deployment process is its non-repeatability and error-prone nature. The development team has the executable files, configuration files, database scripts, and deployment documentation. They provide it to the operations team. All these artifacts are verified on the development environment and not in production or staging. Each team may take a different approach for setting up the runtime environment and the configuration and deployment activities, considering resource constraints and resource availability. In addition, the deployment process needs to be documented for future usage. Now, maintaining the documentation is a time-consuming task that requires collaboration between different stakeholders. Both teams work separately, and hence, there can be a situation where both use different automation techniques. Both teams are unaware of the challenges faced by each other, and hence may not be able to visualize or understand an ideal scenario in which the application works. While the operations team is busy in deployment activities, the development team may get another request for a feature implementation or bug fix. In such a case, if the operations team faces any issues in deployment, they may try to consult the development team, who are already occupied with the new implementation request. This results in communication gaps, and the required collaboration may not happen. There is hardly any collaboration between the development team and the operations team. Poor collaboration causes many issues in the application's deployment to different environments, resulting in back and forth communication through email, chat, calls, meetings, and so on. And it often ends in quick fixes. Challenges for the development team. The competitive market creates on-time delivery pressure. They have to take care of production-ready code management and new feature implementation. The release cycle is often long, and hence the development team has to make assumptions before the application deployment finally takes place. In such a scenario, it takes more time to fix the issues that occurred during deployment in the staging or production environment. Challenges for the operations team. Resource contention. It is difficult to handle increasing resource demands. Redesigning or tweaking. This is needed to run the application in the production environment. Diagnosing and rectifying. They're supposed to diagnose and rectify issues after application deployment in isolation. DevOps with the changing times. Time changes everything. In the modern era, customers expect and demand extremely quick response, and we need to deliver new features continuously to stay in business. Users and customers today have rapidly changing needs. They expect 24/7 connectivity and reliability, and access services over smartphones, tablets, and PCs. As software product vendors, irrespective of whether in the development and/or operations, organizations need to push updates frequently to satisfy customers' needs and stay relevant. In short, organizations are facing new challenges, which we will see diagrammatically. This diagram will represent a change in the behavior of customers or market demand affects the development process. The waterfall model. The waterfall model follows sequential application design process for software development. It comes with good control but lacks revisions. It is a goal-based development but without any scope of revision. The waterfall model has long been used for software development. It has its advantages. Easy to understand, easy to manage, the input and output of each phase is defined. Sequential process, order is maintained. Better control. However, it is only useful in scenarios where requirements are predefined and fixed. As it is a rigid model with a sequential process, we can't go back to any phase and change things. It has its shares of disadvantages. No revision. No outcome or application package until all phases are completed. Not possible to integrate feedback until all phases are completed. Not suitable for changing requirements. Not suitable for long-term and complex projects. The Agile model. Inefficient estimation, long time to market, and other issues led to a change in the waterfall model, resulting in the Agile model. Agile development, or the Agile methodology, is a method of building an application by empowering individuals and encouraging interactions, giving importance to working software, customer collaboration using feedback for improvement, in subsequent steps and responding to change in an efficient manner. It emphasizes customer satisfaction through continuous delivery in small interactions for specific features in short timelines or sprints. This diagram illustrates the working mechanism of Agile. One of the most attractive benefits of Agile development is continuous delivery in short timeframes, or in Agile terms, sprints. Now, it is not a one-time deployment, but multiple deployments. Why? After each sprint, a version of the application with some features is ready for showcasing. It needs to be deployed in specific environments for demonstration, and thus, deployment is no longer a one-time activity. It is very essential from an organization's perspective to meet changing demands of customers. To make it more efficient, communication and collaboration between all cross-functional teams is essential. Many organizations have adopted the Agile methodologies. In such a case, traditional manual deployment processes work as speed barriers for incremental deployments. Hence, it is necessary to change other processes as well, along with a change in the application deployment methodology. One key can't be used for all locks. Similarly, the waterfall model is not suitable for all projects. We need to understand that Agile is customer focused, and feedback is vital. Changes happen based on customer feedback, and release cycles may increase. Just imagine a scenario where inputs are high, but input processing is slow. Consider an example of a shoe company where one department prepares shoes and another department works on final touches and packaging. What would happen if the packaging process was slow and inefficient? Shoes would pile up in the packaging department. Now, let's add a twist to the situation. What if the shoemaking department brings new machines and improves the process of making shoes? Let's say it makes the shoemaking process 2 to 3 times faster. Imagine the state of the packaging department. Similarly, cloud computing and DevOps have gained momentum, which increases the speed of delivery and improves the quality of the end product. Thus, the Agile approach of the application development, improvements in technology, and disruptive innovations and approaches have created a gap between development and operations teams. Collaboration. DevOps attempts to fill these gaps by developing a partnership between the development and operations teams. The DevOps movement emphasizes communication, collaboration, and integration between software developers and IT operations. DevOps promotes collaboration, and collaboration is facilitated by automation and orchestration in order to improve processes. In other words, DevOps essentially extends the continuous development goals of the Agile movement to continuous integration and release. DevOps is a combination of Agile practices and processes leveraging the benefits of cloud solutions. Agile development and testing methodologies helps us meet the goals of continuously integrating, developing, building, deploying, testing, and releasing applications. It provides a mechanism for constant feedback from different teams and stakeholders. It also provides transparency in the form of a platform for collaboration across teams, such as business analysts, developers, and testers. In short, Agile and DevOps are compatible and increase each other's value. Cloud computing, the disruptive innovation. A major challenge is managing the infrastructure for all environments. Visualization in cloud environments can help you get started with this. The cloud helps us overcome this hurdle by providing flexible on-demand resources and environments. It provides distributed access across the globe and helps in the effective utilization of resources. The cloud provides a repository of software tools that can be used on an on-demand basis. We can clone environments and reproduce required versions as and when required. The entire development, test, and production environments can be monitored and managed using the facilities provided by cloud providers. With the advent of cloud computing, it is easy to recreate any piece of infrastructure used by an application using automation. This means that operating systems, OS configuration, runtime environment and configuration, infrastructure configuration, and so forth can all be managed. In this way, it is easy to recreate the production environment exactly in an automated fashion. Thus, DevOps on cloud brings in the best of breed solution from both Agile development and cloud solutions. It helps in providing a distributed Agile environment in the cloud, leading to continuous accelerated delivery. Why DevOps? DevOps is effective because of new methodologies, automation tools, Agile resources of cloud service providers, and other disruptive innovations, practices, and technologies. However, it is not only about tools and technology. DevOps is more about culture than tools or technology alone. There is an urgent need of a huge change in the way development and operations teams collaborate and communicate. Organizations need to have a changing culture and have long-term business goals that include DevOps in their vision. It is important to establish the pain points and obstacles experienced by different teams, business units, and use that knowledge for refining business strategy and fixing goals. If we identify the common issues faced by different sections of an organization and change the strategy to bring more value, then it makes sense. It can be a stepping stone in the direction of DevOps. With old values and objectives, it is difficult to adopt any new path. It is very important to align people with the new process first. For example, a team has to understand the value of the agile methodology, else they will resist using it. They might resist it because they are comfortable with the old process. Hence, it is important to make them realize the benefit, as well as empowering them to bring about the change. Self-dependent teams bring out the best in them when they are empowered. We also need to understand that power comes with accountability and responsibility. Cross-functional teams work together and enhance quality by providing their expertise in the development process. However, it is not an isolated function. Communication and collaboration across teams makes quality way higher. The end objective of DevOps culture is continuous improvement. We learn from our mistakes and it becomes experience. Experience helps us identify robust design patterns and minimize errors in processes. This leads to an enhancement of productivity, and hence, we achieve new heights with continuous innovations. The benefits of DevOps. This diagram covers all the benefits of DevOps. Collaboration among different stakeholders brings many business and technical benefits that help organizations achieve their business goals. In this video, we have learned the basics of DevOps concept, tools and technologies. In the next video, we will learn about DevOps lifecycle. Hi, and welcome to the second video of section 1, the DevOps lifecycle. In the previous video, we learned the basics of DevOps concept, tools and technologies. In this video, we are going to learn about the DevOps lifecycle. Continuous integration, CI, continuous testing, CT, and continuous delivery, CD, are significant parts of DevOps culture. CI includes automating builds, unit tests, and packaging processes, while CD is concerned with the application delivery pipeline across different environments. CI and CD accelerate the application development process through automation across different phases, such as build, test, and code analysis, and enable users to achieve end-to-end automation in the application delivery lifecycle. Continuous integration and continuous delivery or deployment are well supported by cloud provisioning and configuration management. Continuous monitoring helps identify issues or bottlenecks in the end-to-end pipeline and helps make the pipeline effective. Continuous feedback is an integral part of this pipeline, which directs the stakeholders whether they are close to the required outcome or are going in a different direction. This diagram shows a mapping of different parts of an application delivery pipeline with the toolset for Java web applications. We will use a sample Spring application throughout this video for demonstration purposes, which is why the toolset is related to Java. Build automation. An automated build helps us create an application build using build automation tools such as Apache Ant and Apache Maven. An automated build process includes few activities: compiling source code into class files or binary files, providing references to third-party library files, providing the path of configuration files, packaging class or binary files into war files in the case of Java, executing automated test cases, deploying war files on local or remote machines, reducing manual effort in creating the war file. Maven and Ant automate the build process and make it simple, repeatable, and less error-prone, as it is a create once, run multiple times concept. Build automation is the base of any kind of automation in the application delivery pipeline. Build automation is essential for continuous integration, and the rest of the automation is effective only if the build process is automated. All CI servers, such as Jenkins, Atlassian, and Bamboo, use build files for continuous integration and creating their application delivery pipeline. Continuous integration. What is continuous integration? In simple words, CI is a software engineering practice where each check-in made by a developer is verified by two mechanisms. Pull mechanism, executing an automated build at a scheduled time. Push mechanism, executing an automated build when changes are saved in the repository. These are executing by a unit test against the latest changes available in the source code repository. The main benefit of continuous integration is quick feedback based on the result of build execution. If it is successful, all is well. Else, assign responsibility to the developer whose commit has broken the build, notify all stakeholders, and fix the issue. So why is CI needed? Because it makes things simple and helps us identify bugs or errors in the code at a very early stage of development, when it is relatively easy to fix them. Just imagine if the same scenario takes place after a long duration and there are too many dependencies and complexities we need to manage. In the early stages, it is far easier to cure and fix issues. Consider health issues as an analogy, and things will be clearer in this context. Continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. CI is a significant part and in fact a base for the release management strategy of any organization that wants to develop a DevOps culture. Now we will see the immediate benefits of CI. Automated integration with pull or push mechanism. Repeatable process without any manual intervention. Automated test case execution. Coding standard verification. Execution of scripts based on requirement. Quick feedback. Build status notification to stakeholders via email. Teams focused on their work and not in the managing processes. Jenkins, Apache Continuum, BuildBot, GitLab CI, and so on are some examples of open source CI tools. Anthill Pro, Atlassian Bamboo, TeamCity, Team Foundation Server, and so on are some examples of commercial CI tools. Best practices. We will now be looking at best practices that can be useful when considering a continuous integration implementation. Maintain a code repository such as Git or SVN. Check in third-party jar files, build scripts, other artifacts, and so on into the code repository. Execute builds fully from the code repository. Use a clean build. Automate the build using Maven or Ant for Java. Make the build self-testing. Create unit tests. Commit all changes at least once a day per feature. Every commit should be built to verify the integrity of changes. Authenticate users and enforce access control, authentication and authorization. Use alphanumeric characters for build names and avoid symbols. Keep different build jobs to maintain granularity and manage operations in a better way. A single job for all tasks is difficult when trying to troubleshoot. It also helps to assign build execution to slave instances, if that concept is supported by CI server. Back up the home directory of the CI server regularly, as it contains archived builds and other artifacts too, which may be useful in troubleshooting. Make sure the CI server has enough free disk space available, as it stores a lot of build related details. Do not schedule multiple jobs to start at the same time, or use a master-slave concept, where specific jobs are assigned to slave instances so that multiple build jobs can be executed at the same time. Set up an email, SMS, or Twitter notification to specific stakeholders of a project or an application. It is advisable to use customized emails for specific stakeholders. It is advisable to use community plugins. Cloud computing. Cloud computing is regarded as a groundbreaking innovation of recent years. It is reshaping the technology landscape. Without breakthroughs made in appropriate service and business models, cloud computing has expanded to its role as a backbone for IT services. Based on experience, organizations improved from dedicated servers to consolidation and then to virtualization and cloud computing. It has opened various opportunities in terms of the availability of application deployment environments, considering 3 service models and 4 deployment models, as shown in this diagram. There are 4 cloud deployment models, each addressing specific requirements. Public cloud. This cloud infrastructure is available to the general public. Private cloud. This cloud infrastructure is operated for and by a single organization. Community cloud. This cloud infrastructure is shared by a specific community that has shared concerns. Hybrid cloud. This cloud infrastructure is a composition of two or more cloud models. Cloud computing is pivotal if we want to achieve our goals of automation, to inculcate DevOps culture in any organization. Infrastructure can be treated similar to code while creating resources, configuring them, and managing resources using configuration management tools. Cloud resources play an essential role in the successful adoption of DevOps culture. Elastic, scalable, and pay-as-you-go resource consumption enables organizations to use the same type of cloud resources in different environments. The major problems in all the environments are inconsistency and limited capacity. Cloud computing solves this problem as well as those of economic benefits. Configuration management. Configuration management, CM, manages changes in the system or, to be more specific, the server runtime environment. Let's consider an example where we need to manage multiple servers with the same kind of configuration. For example, we need to install Tomcat on each server. What if we need to change the port on all servers, or update some packages or provide rights to some users? Any kind of modification in this scenario is a manual and, if so, error-prone process. As the same configuration is being used for all the servers, automation can be used here. Automating installation and modification in the server runtime environment or permissions brings servers up to spec effectively. CM is also about keeping track or versions of details related to the state of specific nodes or servers. It is a far better situation when we need and update themselves. A centralized change can trigger this, or nodes can communicate with the CM server about whether they need to update themselves. CM tools make this process efficient when only changed behavior is updated, and the entire installation and modification isn't applied again to the server nodes. There are many popular configuration management tools in the market, such as Chef, Puppet, Ansible, and Salt. Each tool is different in the way it works, but the characteristics and end goal are the same: to bring standardized behavior to the state changes of specific nodes without any error. Continuous delivery or continuous deployment. Continuous delivery and continuous deployment are used interchangeably more often than not. However, there is a small difference between them. Continuous delivery is a process of deploying an application in any environment in an automated fashion and providing continuous feedback to improve its quality. Continuous deployment, on the other hand, is all about deploying an application with the latest changes to the production environment. In other words, we can say that continuous deployment implies continuous delivery, but the converse isn't true. Continuous delivery is significant because of the incremental releases after short spans of implementation, or sprint in agile terms. To deploy a future-ready application from development to testing may include multiple iterations in a sprint due to changes in the requirements or interpretation. However, at the end of a sprint, the final feature-ready application is deployed to the production environment. Like we discussed about having multiple deployments in a testing environment, even for a short span of time, it is advisable to automate such a thing. Scripts to create infrastructure and runtime environments for all environments are useful. It is easier to provision resources in such environments. For example, to deploy an application in Microsoft Azure, we need few resources. The Azure web app configured with specific types of resources. A storage account to store backpack files to create the database. Then, we need few steps. 1. Create a SQL Server instance to host the database. 2. Import backpack files from the storage account to create a new database. 3. Deploy the web application to Microsoft Azure. In this scenario, we may consider to use a configuration file for each environment with respect to naming conventions and paths. However, we need similar types of resources in each environment. It is possible that the configuration of resources changes according to the environment, but that can be managed in a configuration file for each environment. Automation scripts can use configuration files based on the environment, create resources and deploy an application into it. Hence, repetitive steps can be easily managed by an automated approach, and this is helpful both in continuous delivery and continuous deployment. Best practices for continuous delivery. There are some common practices we should follow to implement continuous delivery. Plan to automate everything in an application delivery pipeline. Consider a situation where just a single commit only is required to deploy an application in the target environment. It should include compilation, unit test execution, code verification, notification, instance provisioning, setting up runtime environment, and deploying. You must remember to automate repetitive tasks, difficult tasks, manual tasks. Develop and test the newly implemented bug fixes in a production-like environment. It is possible now with pay-per-use resources provided by cloud computing. Deploy frequently in the development and test environments to gain experience and consistency. Continuous monitoring. Continuous monitoring is a backbone of end-to-end delivery pipeline, and open source monitoring tools are like toppings on an ice cream scoop. It is desirable to monitor at almost every stage in order to have transparency about all the processes, as shown in the diagram. It also helps us troubleshoot quickly. Monitoring should be a well thought out implementation of a plan, and it should be a part of each of the components mentioned in the diagram. Consider monitoring practices for continuous integration to continuous delivery or deployment. There is a likely scenario where end-to-end deployment is implemented in an automated fashion, but issues arise due to coding problems, query-related problems, infrastructure-related issues, and so on. We can consider different types of monitoring, as shown in the diagram. However, there is normally a tendency to monitor only infrastructure resources. The question one must ask is whether it is enough, or whether we must focus on other types of monitoring as well. To answer this question, we must have a monitoring strategy in place in the planning stage itself. It is always better to identify stakeholders, monitoring aspects, and so on, based on the culture and experience of an organization. Continuous feedback. Continuous feedback is the last important component in the DevOps culture and provides a means of improvement and innovation. Feedback always provides improvement if it comes from stakeholders who know what they need and how the outcome should be. Feedback from the customer after deployment activities can serve as inputs to developers for improvement, as shown in the diagram, and its correct integration will make the customer happy. Here, we're considering a situation where a feature implementation is provided to the stakeholders, and they provide their feedback. In the waterfall model, the feedback cycle is very long, and hence developers may not be aware about whether the end product is what the customers asked for, or whether the interpretation of what needs to be delivered was changed somewhere. In Agile or DevOps culture, a shorter feedback cycle makes a major difference, as stakeholders can actually see the results of a small implementation phase, and hence the outcome is verified multiple times. Customers are not satisfied, and feedback is available at a stage where it is not very tedious to change things. In the waterfall model, this would have been a disaster, as feedback used to be received very late. With time and dependencies, the complexity increases, and changes in such situations takes a long time. In addition to this, no one remembers what they wrote 2 months back. Hence, a faster feedback cycle improves the overall process and connects endpoints, as well as finding patterns in mistakes, learning lessons, and using improved patterns. However, continuous feedback not only improves the technical aspects of implementation, but also provides a way to assess current features and whether they fit into the overall scenario, or is there still room for improvement. It's important to realize that continuous feedback plays a significant role in making customers happy by providing an improved experience. Great! In this video, we have learned the life cycle of DevOps. In the next video, we will learn about tools and technologies. Welcome to the next video of the first section, Tools and Technologies. In the previous video, we have learned about DevOps lifecycle. In this video, we will learn about the tools and technologies. Tools and technologies play an important role in the DevOps culture. However, it is not the only part that needs attention. For all parts of the application delivery pipeline, different tools, disruptive innovations, open source initiatives, community plugins, and so on are required to keep the entire pipeline running to produce effective outcomes. Code repositories, Git. Subversion is a version control system that is used to track all the changes made to files and folders. Using this, you can keep track of the applications being built. Features added months ago can also be tracked using the version code. It is all about tracking the code. Whenever any new feature added or new code made, it is first tested and then committed by the developer. Then, the code is sent to the repository to track the changes, and the new version is given to it. A comment can also be made by the developer so that any other developers can easily understand changes that were made. Other developers only have to update their checkout to see the changes made. Advantages. There are some advantages of using source code repositories. Many developers can work simultaneously on the same code. If a computer crashes, the code can still be recovered, as it had been committed in the server. If a bug occurs, the new code can be easily reverted to the previous version. Git is an open source distributed version control system designed to handle small to enormous projects with speed and efficiency. It is easy to learn and has good performance. It comprises a full-fledged repository and version control tracking capabilities independent of a central server or network access. It was developed and designed by Linus Torvalds in 2005. Characteristics. There are some significant characteristics of Git. It provides support for nonlinear development. It is compatible with existing systems and protocols. It ensures the cryptographic authentication of history. It has well-designed pluggable merge strategies. It consists of toolkit-based designs. It supports various merging techniques such as resolve, octopus, and recursive. Differences between SVN and Git. SVN and Git are both very popular source code repositories. However, Git is getting more popular in recent times. Detailed description of Subversion and Git is illustrated in this table. Subversion, centralized version control system. Git, distributed version control system. Subversion, snapshot of a specific version of the project is available on the developer's machine. Git, complete clone of a full-fledged repository is available on the developer's machine. Subversion, performance operations such as commit, merge, blame, and revert, verifies branch and log from a central repository. Git, perform operations such as commit, merge, and blame, and verifies branch and log from a local repository, along with pull and push operation to a remote repository if the developer needs to share work with others. Subversion, file changes are included in the next commit. Git, file changes have to be marked explicitly and only then they are included in the next commit. Committed work is directly transferred to the central repository, and hence, direct connection to the repository must be available. Committed work is not directly transferred to the remote repository and committed to local repository, and to share it with other developers, we need to push it to the remote repository, in which case, we need a connection to the remote repository. Each commit gets ascending revision numbers. Each commit gets commit hashes rather than ascending revision numbers. Short learning curve. Long learning curve. Build tools. Maven. Apache Maven is a build tool with the Apache 2.0 license. It is used for Java projects and can be used in a cross-platform environment. It can also be used for Ruby, Scala, C# and other languages. These are the important features of Maven. A Project Object Model, POM, XML file contains information about the name of the application, owner information, how the application distribution file can be created, and how dependencies can be managed. Example pom.xml file. The pom.xml file has predefined targets such as validate, generate sources, process sources, generate resources, process resources, compile, process test sources, process test resources, test compile, test, package, install, and deploy. This is an example of a sample pom.xml file used in Maven. Continuous integration tools. Jenkins. Jenkins was originally open source continuous integration software written in Java under the MIT license. However, Jenkins 2, an open source automation server that focuses on any automation, including continuous integration and continuous delivery. Jenkins can be used across different platforms, such as Windows, Ubuntu, Debian, Red Hat, Fedora, Mac OS X, OpenSUSE, and FreeBSD. Jenkins enables users to utilize continuous integration services for software development in an agile environment. It can be used to build freestyle software projects based on Apache Ant and Maven 2 or Maven 3. It can also execute Windows batch commands and shell scripts. It can be easily customized with the use of plugins. There are different kinds of plugins available for customizing Jenkins based on specific needs for setting up continuous integration. Categories of plugins include source code management, the Git, CVS, and Bazaar plugins, build triggers, the accelerated build now and build flow plugins, build reports, the code scanner and disk usage plugins, authentication and user management, the Active Directory and GitHub OAuth plugins, and cluster management and distributed build, Amazon EC2 and Azure Slave plugins. Jenkins accelerates the software development process through automation. Key features and benefits. Here are some striking benefits of Jenkins. Easy install, upgrade and configuration. Supported platforms, Windows, Ubuntu, Debian, Red Hat, Fedora, CentOS, Mac OS X, OpenSUSE, FreeBSD, OpenBSD, Solaris, and Gentoo. Manages and controls development lifecycle processes. Non-Java projects supported by Jenkins, such as .NET, Ruby, PHP, Drupal, Perl, C++, Node.js, Python, Android, and Scala. Development methodology of daily integrations verified by automated builds. Every commit can trigger a build. Jenkins is a fully featured technology platform that enables users to implement CI and CD. The use of Jenkins is not limited to CI and CD. It is possible to include a model and orchestrate the entire pipeline with the use of Jenkins, as it supports shell and Windows batch command execution. Jenkins 2.0 supports a delivery pipeline that uses a domain-specific language, DSL, for modeling entire deployments or delivery pipelines. The pipeline as code provides a common language, DSL, to help the development of operations teams to collaborate in an effective manner. Jenkins 2 brings a new GUI with stage view to observe the progress across the delivery pipeline. Jenkins 2.0 is fully backward compatible with the Jenkins 1.x series. Jenkins 2 now requires Servlet 3.1 to run. You can use embedded Windstone Jetty or a container that supports Servlet 3.1, such as Tomcat 8. GitHub, CollabNet, SVN, TFS code repositories, and so on are supported by Jenkins for collaborative development. Continuous integration, automate build and the test automated testing, continuous testing, package and static code analysis. Supports common test frameworks such as HP ALM tools, JUnit, Selenium, and MS Test. For continuous testing, Jenkins has plugins for both. Jenkins Slave can execute test suites on different platforms. Jenkins supports static code analysis tools such as code verification by check style and find bug. It also integrates with Sonar, continuous delivery and continuous deployment. It automates the application deployment pipeline, integrates with popular configuration management tools, and automates environment provisioning. To achieve continuous delivery and deployment, Jenkins supports automatic deployment. It provides a plugin for direct integration with IBM UDeploy. Highly configurable. Plugins-based architecture that provides support to many technologies, repositories, build tools, and test tools. It has an open source CI server and provides over 400 plugins to achieve extensibility. Supports distributed builds. Jenkins supports master or slave mode, where the workload of building projects is delegated to multiple slave nodes. It has a machine consumable remote access API to retrieve information from Jenkins for programmatic consumption, to trigger a new build, and so on. It delivers a better application faster by automating the application development lifecycle, allowing faster delivery. The Jenkins build pipeline, quality gate system, provides a build pipeline view of upstream and downstream connected jobs as a chain of jobs, each one subjecting the build to quality assurance steps. It has the ability to define manual triggers for jobs that require intervention prior to execution, such as an approval process outside of Jenkins. In this diagram, quality gates and orchestration of build pipeline are illustrated. Jenkins can be used with these tools in different categories as shown here. Configuration management tools. Chef Software Configuration Management, SCM, is a software engineering discipline comprising tools and techniques that an organization uses to manage changes in software components. It includes technical aspects of the project, communication, and control of modifications to the project during development. It's also called software control management. It consists of practices for all software projects ranging from development to rapid prototyping and ongoing maintenance. It enriches the reliability and quality of service. Chef is a configuration management tool used to transform infrastructure into code. It automates the building, deploying, and managing of the infrastructure. By using Chef, infrastructure can be considered as code. The concept behind Chef is that of reusability. It uses recipes to automate the infrastructure. Recipes are instructions required for configuring databases, web servers, and load balancers. It describes every part of the infrastructure and how it should be configured, deployed, and managed. It uses building blocks known as resources. A resource describes part of the infrastructure, such as the template, package, and files to be installed. These recipes and configuration data are stored on Chef servers. The Chef client is installed on each node of the network. A node can be a physical or virtual server. As shown in this diagram, the Chef client periodically checks the Chef server for the latest recipes and to see whether the node is in compliance with the policy defined by the recipes. If it is out of date, the Chef client runs them on the node to bring it up to date. Features. There are some important features of the Chef configuration management tool. The Chef server. It manages a huge number of nodes. It maintains a blueprint of the infrastructure. The Chef client. It manages various operating systems such as Linux, Windows, Mac OS, Solaris, and FreeBSD. It provides integration with cloud providers. It is easy to manage the containers in a versionable, testable, and repeatable way. Chef provides an automation platform to continuously define, build, and manage cloud infrastructure used for deployment. It enables resource provisioning and the configuration of resources programmatically, and it will help in the deployment pipeline in order to automate provisioning and configuration. These are three basic concepts of Chef that will enable organizations to quickly manage any infrastructure. Achieving the desired state. Centralized modeling of IT infrastructure. Resource primitives that serve as building blocks. Cloud service providers. AWS and Microsoft Azure are popular public cloud providers right now. They provide cloud services in different areas, and both have their strong areas. Based on the organization's culture and past partnerships, either can be considered after a detailed assessment based on requirements. This is a side-by-side comparison. Container technology. Containers use OS-level virtualization, where the kernel is shared between isolated user spaces. Docker and OpenVZ are popular open-source examples of OS-level visualization technologies. Docker. Docker is an open-source initiative to wrap code, the runtime environment, system tools, and libraries. Docker containers share the kernel they are running on, and hence start instantly and in a lightweight manner. Docker containers run on Windows as well as Linux distributions. It is important to understand how containers and virtual machines are different. Here is a comparison table of virtual machines and containers. Monitoring tools. There are many open source tools available for monitoring resources. Xenos and Nagios are two of the most popular open source tools and have been adopted by many organizations. Xenos. Xenos is an agentless and open source management platform for applications, servers, and networks released under the GNU General Public License (GPL) version 2 and is based on the Zope application server. Xenos Core consists of the extensible programming language Python, object-oriented web server Zope, monitoring protocol network, graph and log time series data by RRD tool, MySQL, and event-driven networking engine Twisted. It provides an easy-to-use web portal to monitor alerts, performance, configuration, and inventory. In this diagram, Xenos features are illustrated. Nagios. Nagios is a cross-platform and open-source monitoring tool for infrastructure and networks. It monitors network services such as FTP, HTTP, SSH, and SMTP. It monitors resources, detects problems, and alerts stakeholders. Nagios can empower organizations and service providers to identify and resolve issues in a way that outages have minimal impact on the IT infrastructure and processes, hence ensuring highest adherence to SLAs. Nagios can monitor cloud resources such as compute, storage, and network. Deployment orchestration or continuous delivery. Jenkins. The build pipeline, also called the deployment or application delivery pipeline, can be used to achieve end-to-end automation for all operations, including continuous integration, cloud provisioning, configuration management, continuous delivery, continuous deployment, and notifications. These are Jenkins plugins that can be used for overall orchestration of all the activities involved in end-to-end automation. Continuous integration, Jenkins. Configuration management, Chef. Cloud service providers, AWS, Microsoft Azure. Container technology, Docker. Continuous delivery or deployment, SSH. End-to-end orchestration, Jenkins plugins. Here is a sample representation of end-to-end automation using different tools. Jenkins can be used to manage unit testing and code verification. Chef can be used for setting up a runtime environment. Knife plugins can be used for creating a virtual machine in AWS or Microsoft Azure. The build pipeline or deployment pipeline plugins in Jenkins can be used for managing deployment orchestration. From a single pipeline dashboard, we can view the status of all the builds that are configured in the pipeline. Each build in the pipeline is a kind of quality gate. If one build fails, then the execution won't go further. Additional dimensions can be added, such as notification based on compilation failures, unit test failures, or for unsuccessful deployment. The final deployment can be based on some sort of permission from a specific stakeholder. Consider a scenario for a parameterized build or promoted build concept. What should we do? All will be revealed in the sections to follow. The DevOps dashboard. One of the most liked components of DevOps culture is the dashboard or GUI that provides a combined status of all end-to-end activities. For automation tools, an easy-to-use web GUI is handy for managing resources. For end-to-end automation in application deployment activities, multiple open source or commercial tools are used. There is a high possibility that a single product may not be used for all activities. For example, Git or SVN as the repository, Jenkins as the CI server, and IBM Urban Code Deploy as the deployment orchestration tool. In such a scenario, it is easier if there is a single pane of glass view where we can track multiple tools for a specific application. Hygeia is an open source DevOps dashboard that provides a way to track the status of a deployment pipeline. It basically tracks 6 different areas as of now, including features, code repository, builds, Jenkins, Hudson, quality, monitoring, and deployment. In this video, we've successfully learned about tools and technologies. In the next video, we will learn an overview of a sample Java EE application. Hi, and welcome to the last video of the first section, an overview of a sample Java EE application. In the previous video, we have learned about tools and technologies. In this video, we are going to use Pet Clinic available on GitHub. It is a sample Spring application with JUnit test cases already written for it. The Pet Clinic sample application can be used to build simple and robust database-oriented applications that demonstrate the use of Spring's core functionality. It is accessible via a web browser. A few use cases. Add a new pet owner, a new pet, and information pertaining to a visit to the pet's visitation history to the system. Update the information pertaining to a pet and pet owner. View a list of veterinarians and their specialities, pet owner, a pet, and a pet's visitation history. Once a WAR file is created, we can deploy it in Tomcat or another web server, and to verify it on the local host. You will see something like this. The list of tasks. These are the tasks we will try to complete in the rest of the sections. Jenkins installation, configuration, UI personalization, Java configuration, Java_home in Jenkins, Maven or Ant configuration in Jenkins, plugin installation and configuration in Jenkins, security, access control, authorization and project-based security in Jenkins, Jenkins build configuration and execution, email notification configuration, deploying a WAR file to a web application server, creating and configuring a build or deployment pipeline, installing and configuring Chef, installing and configuring Docker, creating and configuring a virtual machine in AWS, Microsoft Azure, and containers, deploying a WAR file into a virtual machine and a container, configuring infrastructure monitoring, orchestrating the application delivery pipeline using Jenkins plugins. In this section, we learned about the difficulties faced by development and operations teams in a traditional environment and how agile development helps in such a scenario. What has changed after the arrival of agile development, and what challenges has it brought with its arrival? We have covered the important aspects of the DevOps culture, including continuous integration and continuous delivery. We also covered details regarding cloud computing and configuration management that enhance the processes and help to adopt DevOps culture. In terms of tools and technologies, we covered a brief overview of SVN, Git, Apache Maven, Jenkins, AWS, Microsoft Azure, Chef, Nagios, Xenos, and the DevOps dashboard, Hygia. In the next section, we will see how to install and configure Jenkins 2.0 and implement continuous integration using a sample Spring application available on GitHub. Hi, and welcome to the second section of this course, Continuous Integration with Jenkins 2. This section describes in detail how Jenkins plays an important role in continuous integration. It covers how to prepare a runtime environment for application lifecycle management and configure it with Jenkins. It manages all the aspects of running a build to create a distribution file or web application archive (WAR) file for deployment by integrating with a source code repository such as SVN or Git for a sample Java EE application. You will learn how to install and configure Jenkins, and you will be able to get end-to-end experience in build job creation and configuration, static code analysis, notifications, Jenkins plugins, and so on, as well as details on what exactly the sample application is all about. The section will demonstrate the following topics: an introduction to Jenkins, installing Jenkins with plugins, configuring Java and Maven or Ant in Jenkins, creating and configuring a build job for a Java application with Maven, the dashboard view plugin, overview and usage, sending email notifications based on build status, integrating Jenkins and Sonar. Now we will see the first video of section 2, installing Jenkins and the Jenkins dashboards. In this video, we will learn how to install Jenkins and Jenkins dashboards. Jenkins provides us with multiple ways to install it for all types of users. We can install it on at least these operating systems: Ubuntu Debian, Windows, Mac OS X, OpenBSD, FreeBSD, OpenSUSE, Gentoo, CentOS, Fedora, or Red Hat. One of the easiest options I recommend is to use a WAR file. A WAR file can be used with or without a container or web application server. Having Java is a must before we try to use a WAR file for Jenkins, which can be done by using these functions. Download the jenkins.war file from this site. Open command prompt in Windows or a terminal in Linux. Go to the directory where the jenkins.war file is stored and execute this command. Once Jenkins is fully up and running, as shown in the screen, explore it in the web browser by visiting this link. By default, Jenkins works on port 8080. Execute this command from the command line. For HTTPS, use this command. Once Jenkins is running, visit the Jenkins home directory. In our case, we've installed Jenkins 2 on CentOS 6.7 virtual machine. Go to Home, Username, .jenkins, as shown in the screen. If you can't find the .jenkins directory, make sure hidden files are visible. In CentOS, press Ctrl and H to make hidden files visible. Setting up Jenkins. Now that we've installed Jenkins, let's verify whether Jenkins is running. Open a browser and navigate to http://localhost:8080 or http:// your IP address :8080. If you have used Jenkins earlier and recently downloaded the Jenkins 2 WAR file, it will ask you for a security setup. To unlock Jenkins, go to the .jenkins directory and open the initial admin password file from the secret subdirectory. Copy the password from that file, paste it in the administrator password box and click on Continue. Clicking on Continue will redirect you to the Customize Jenkins page. Click on Install Suggested Plugins. The installation of the plugins will start. Make sure that you have a working internet connection. Once all the required plugins have been installed, you will see the Create First Admin User page. Provide the required details and click on Save and Finish. Jenkins is ready. Our Jenkins setup is complete. Click on Start using Jenkins. Get Jenkins plugins from this site. The Jenkins Dashboard. The Jenkins Dashboard is a simple and powerful place where we can manage all builds and therefore manage the application delivery pipeline as well. Open http://localhost or your IP address :8080 from browser. Log in with the user credentials we created earlier. It will direct us to the dashboard. Let's understand the dashboard parameters. New item. It is used to create a new build job, pipeline, or build flow in Jenkins 2. Manage Jenkins. It allows a Jenkins 2 administrator to manage plugins, users, security, nodes, credentials, global tool configuration, and so on. To know about the existing nodes used for build execution, click on Manage Nodes. The master node entry will be available. It is the node where Jenkins is installed. We can add multiple slave nodes to distribute the load, which we will learn later in this section. Now that we've installed Jenkins and become familiar with the Jenkins dashboard, the next step is to configure different tools that are used for build execution and create a base for continuous integration. In the next one, we'll learn how to install and configure Java, Maven, and Ant. Hi again, and welcome to the next video of the second section. Configure Java and Mavens in Jenkins to build job for a Java application with Maven. In the previous video, we have learned how to install Jenkins and the Jenkins dashboards. In this video, we will learn how to configure and build job for a job application with Maven by using Jenkins. In Jenkins 2, the Global Tool Configuration section has been introduced, which is a good move. All major configurations related to external tools, their locations, and automatic installer tools can be made in this section. Earlier, these configurations were part of Configure System, which used to make that page a bit cluttered. Configuring Java. To configure Java, provide a name and the Java_home path, or check Install Automatically checkbox. Configuring Maven. To configure Maven, download the Maven installer from https://maven.apache.org/download.cgi and extract it to the directory on your Jenkins virtual machine. In the Global Tool Configuration section, provide the name and Maven_home path, or check Install Automatically checkbox. That's it. Our major configuration for running a simple build is done. Now, let's go to the home page of the Jenkins dashboard to create and configure a build job. Jenkins builds configured with Maven understands how Maven works and what is required in terms of execution. It uses pom.xml to set up and create package files from the source files. Now let's perform steps to create and configure a new build job. Go to the Jenkins dashboard and click on New Item. Go through all the available options of the types of jobs we can create. In our case, let's create a freestyle project for a demo. Enter an item name, such as Pet Clinic, then select Freestyle Project. Now click on OK to continue. Let's verify what this operation does. Go to the Jenkins home directory and navigate to the jobs directory. We can see that the directory has been created for the newly created job with the same name, as shown in the screen. Awesome, we have successfully configured Java and Maven in Jenkins and generated a job for a Java application with Maven. In the next video, we will learn how to configure and authenticate source code on GitHub. Welcome to the next video of Section 2, Configuring and Authenticating Source Code on GitHub. In the previous video, we have learned how to configure Java and Mavens in Jenkins to build job for a Java application with Maven. In this video, we will see how to configure and authenticate source code on GitHub. The next step is to configure a source code repository with the build job. We will use the open source Spring application hosted on GitHub, as explained in the previous section. After that, we will get a URL similar to this site. Create a GitHub account and fork repository from this site. To download a Windows application, navigate to this site and click on Downloads for Windows. Let's generate a new SSH key to use for authentication. Open a terminal on a CentOS virtual machine with Git installed. Run this command, which will substitute your GitHub email address. Press Enter when you are prompted with Enter file in which to save the key. Add your SSH key to SSH-agent. Verify the newly generated keys in the .ssh folder. To configure your GitHub account to use the new SSH key, add it to your GitHub account. Visit your account page and click on Settings. In the Personal Settings sidebar, click on SSH and GPG keys. Click on New SSH key. Open /ID_RSA.pub in a text editor your virtual machine and copy the content. In the title field, add a descriptive label for the new key and paste the copied key content in the key field. Click on Add SSH key. Verify the added SSH key. Now, let's verify authentication. Open Terminal and type this following command and press Enter. If we get successfully authenticated, then we can access Git repository without credentials. Awesome! In this video, we've successfully configured and authenticated source code on GitHub. In the next video, we'll learn how to configure build job and configure JUnit. Welcome to the next video of Section 2, Configuring build job and JUnit. In the previous video, we have configured and authenticated source code on GitHub. In this video, we will learn how to configure build job and JUnit. Now that Git authentication is done with, let's configure a pet clinic build job. Click on the pet clinic build job on the Jenkins dashboard. Then, click on the configure link. Under Source Code Management, provide the GitHub URL for the sample Spring project we forked earlier. We will configure build triggers and the build environment. Under Build, click on Add Build Step and select Invoke Top-Level Maven Targets. Select the Maven version we configured in Global Tools configuration. Enter the Maven target and click on Save. Let's manually trigger the build by clicking on Build Now after the build is complete. Click on the build number, the one with the hash symbol. Open console output. Verify the Git operations executing before Maven target execution. Once source code is available in the build jobs workspace, the Maven target will be executed and the war file created. Verify the build status. To verify the workspace of a build job, click on the workspace link. Verify all the files available in the workspace. We can find these files in the .jenkins folder under the specific build job. Our sample application has JUnit test cases, and to execute them, we need to configure JUnit related settings in the build job configuration. Under Post Build Actions, select Publish JUnit Test Result Report. Provide a path for test report XMLs based on the workspace. Click on Apply and then click on Save. After you configure the JUnit settings for the build, wait for a scheduled build execution, or click on Build Now. Verify the build status on the Jenkins dashboard and you will see the test result link with a small summary. Click on Test Result. Verify all test execution statuses package-wise. The page also provides information related to duration and failed test cases. Great work! We have successfully configured build job and JUnit. In the next video, we will cover the Dashboard View plugin, which helps us customize the view for build jobs. Hello again and welcome to the next video of Section 2, the Dashboard View plugin, Overview and Usage. In the previous video, we have learned how to configure build job and JUnit. In this video, we will provide a different view implementation based on a portal kind of layout. We can select different build jobs to be included in a new view and configure different portlets for the view. Go to Plugin Manager from Manage Jenkins and click on the Available tab. Search for the Dashboard View plugin and click on Install without restart. Once the plugin has been installed successfully, we can create a new view by clicking on the plus sign on the Jenkins dashboard. Enter a view name, select the view type, and click on OK. Click on Edit and configure dashboard portlets for the top, left column, right column, and bottom. We can use different portlets such as Test Statistics Chart and Trends. Add different portlets based on your requirements into the view and save it. Here's a sample view. After we run the build job, we can find a test result chart on the build job's dashboard as well. Now we'll look at one of the most popular features of Jenkins, distributed builds. Great! We have successfully learned about the Dashboard View plugin. Consider a scenario where you want different Java applications that need different JDK versions to compile source files. How do you manage such a situation effectively? We'll find out in the next section. In the next video, we'll see how to manage nodes. Welcome to the next video of Section 2, Managing Nodes. In the previous video, we have learned about the Dashboard View plugin, Overview and Usage. In this video, we will provide a master-slave concept for managing the aforementioned scenarios. We can assign different build jobs to different slaves in the build configuration and use the master-slave system to manage its overall lifecycle. The master node itself can execute the build if a slave node is not configured explicitly in the build job configuration. There are quite a few reasons for using this feature. Build jobs require resources and they compete for resource availability. A different runtime environment is required for different build jobs. It distributes the load across slave nodes. To make things clearer, we need not install Jenkins on the slave nodes. We only need to configure the slave nodes properly, which we will now cover. The only requirements are: the configurations and runtime environment have to be available on the slave node. The path needs to be configured correctly on the master node for the runtime environments or tools used by the slave node for execution. Creating and configuring slave node in Jenkins 2. Click on the Manage Jenkins link on the Jenkins dashboard. Verify that only the master node's entry is available. To add a new node, click on New Node in the left sidebar. enter a node name in the node name field and click on OK. The next step is to configure the newly created node. Enter a remote root directory, which will store details related to the build jobs on slave nodes. Give labels to this node. Labels can be used to assign different build jobs to specific slave machines. In Jenkins 2, on creating a slave node and configuring it, as shown in the screen. Verify the status of the slave node from the Jenkins dashboard. Now, we can see two nodes in the Jenkins dashboard. Configuring the build job for master and slave node. To configure the build job to run on the master, open its build configuration and in General section, select Restrict where this project can be run. In Label expression, enter the label of the master node. To configure the build job to run on the slave node, enter the label of the slave node in Label expression. We can also configure the JDK or some other required path for build execution. To configure tools specific to the slave node, click on Configure in the Manage Nodes section. In Node Properties, configure tool locations for the slave node as shown here. Great, we have successfully learned how to manage nodes. In the next video, we will see how to configure email notifications. Welcome to the next video of Section 2, Sending Email Notifications based on Build Status. In the previous video, we have learned about managing nodes. In this video, we will learn how to send email notifications based on build status. Notifications are always helpful in case of failures. Consider a scenario where a build failure or test case failure has to be notified to a specific set of stakeholders. In such a situation, it is desirable to have email notifications. We will use Gmail configuration for setting up email notifications. First, go to this site and click on Turn on access for less secure apps, as shown here, to send email notifications from Jenkins 2. Click on Manage Jenkins and go to the Configure System section. Go to the Email Notification subsection and enter the appropriate values for SMTP server and default user email suffix. Check the Use SMTP authentication box and enter a username and password. Check the Use SSL checkbox and enter details for SMTP port and reply to address. Finally, select Test Configuration by sending test email. If you set everything up correctly, you will see a message saying, "Email was successfully sent." To verify email notifications, simulate a failure in a build job. Open any build job and click on Configure. In Post Build Actions, click on Add Post Build Action and configure it like this. Now select Email Notification. Then enter a list of recipients. Select Send Email for every unstable build and send separate emails to individuals who broke the build. In our case, we execute a compile goal against the Maven build and we wanted to publish a JUnit test result to simulate a failure. We can see that the compilation of file is successful, but the post-build action fails and it triggers an email notification based on the configuration. It looks like the email is received. It contains a stack trace of the execution. Excellent work! We have successfully learned how to send an email notification based on build status. In the next video, we will learn about integrating Jenkins and Sonar. Welcome to the last video of Section 2, Integrating Jenkins and Sonar. In the previous video, we have learned how to send email notifications based on build status. In this video, we will learn how to integrate Jenkins and Sonar. SonarQube is an open source tool for managing the code quality of an application. It manages 7 axes of code quality, such as architecture and design, duplications, unit tests, potential bugs, complexities, coding rules, and comments. It covers programming languages and formats such as ABAP, C and C++, C#, COBOL, CSS, Erlang, Flex and ActionScript, Groovy, Java, JavaScript, JSON, Objective-C, PHP, PL and I, PL and SQL, Puppet, Python, RPG, Swift, VB.NET, Visual Basic 6, and XML. One of the most striking features is its extensibility. It is easy to cover new languages and add rule engines using an extension mechanism in the form of plugins. To install the SonarQube plugin, we will use few steps. Go to Manage Jenkins and click on Manage Plugins. Click on Available, search for the SonarQube plugin and install it by clicking on Install Without Restart. Download Sonar from this site. Extract the installable directory from the zip file and go into the bin subdirectory. Select the installable directory based on your OS and run the Start Sonar file, which you can see in the screen. Once Sonar is set up and running, open a browser and visit the local host. Then you will get the Sonar dashboard. We will see an important step for Jenkins 2 and Sonar integration is the security token. Go to the My Accounts link in the top right corner, click on the Security tab, and then on Generate Tokens. Enter a token name and click on Generate. Copy the token value and click on Done. Verify the tokens column in the On dashboard. Once we have a security token ready, we need to integrate Jenkins and Sonar. In the Manage Jenkins section, click on Configure System and add SonarQube servers. Here provide a server URL and server authentication token and save the settings. In Global Tool Configuration, configure SonarQube scanner installations as well. Once all Sonar related installations and configurations are completed, we need to add a build step to execute SonarQube scanner. Run the build job with a few steps. First, we need sonar-project.properties to configure Sonar with a specific application. In our sample application, the sonar-project.properties file is already available. Next, verify the console output of a build job for Sonar execution. Let's verify the Sonar UI at the local host site. In the Project section, we can find project details available now. Click on the project name. We can see the result of the analysis here. Quality Gate shows passed. It provides details about technical debt, duplications, and structure too. Quality gates can be defined in the Sonar dashboard. We've used the default quality gate here. To verify lines of code, complexity, and comment lines data, click on the Structure tab in the Sonar dashboard. To get more insight into issues in specific files, click on the Technical Debt tab and click on the bubbles on the chart. Sonar stores historical data in 24-hour slices. Good job! We've successfully integrated Jenkins and Sonar. This video concludes the second section of this course. In this section, we learned about some new features in Jenkins 2, why Jenkins is so popular, and how to install it. We discussed the improvements with respect to security and plugin installations during setup and how to configure Java and Maven. We took a look at what happens in the background when we create a new job in Jenkins, how to authenticate with Git, and how to configure Git in Jenkins. We then performed a unit test execution in a sample Spring application and configured the Dashboard View plugin with different portlets for customized views. We then learned how to manage the master and slave nodes for load distribution and managing different environments as required, how to configure email notifications for build status, and how to integrate Sonar and Jenkins. In the next section, we will look at one of the most important aspects in terms of the orchestration of the end-to-end pipeline of application delivery. We will discuss the pipeline concept of Jenkins 2 and the build pipeline plugin. Hi, and welcome to the third section of this course, building the code and configuring the build pipeline. This section describes in detail how to create the pipelines of different jobs for a sample Java Enterprise Edition Java EE application. It will also cover the deployment of an application to a local web or application server and the configuration of a build pipeline for the life cycle of continuous integration. This way, Jenkins users can model application delivery pipelines as the code. Once we make it into code, we can store in a code repository and it can be managed in a better way. An important benefit is collaboration. As it can be stored in version control, different teams can reuse it for different operations based on the environment. Readers will learn how to manage the lifecycle of continuous integration, including pulling code from a code repository, building the code, executing unit tests, and static code analysis using different jobs. The section will demonstrate the following topics: the built-in delivery pipelines of Jenkins 2, build pipeline configuration for end-to-end automation for managing the lifecycle of continuous integration, deploying a WAR file from Jenkins to a local Tomcat server. Now we will see the first video of section 3, creating built-in delivery pipelines. In this video, we will learn how to create delivery pipelines using a domain-specific language, DSL. First, go to the Jenkins dashboard and click on New Item. Enter an item name, say Pet Clinic-Pipeline, and select Pipeline, and click on OK. In case you have an existing pipeline available, you can create a new pipeline by copying from it. Go to Advanced Project Options. For the purpose of learning, input echo Hello from Pipeline Demo in the script box. Then, click on Save to save the configuration. As we haven't created any stage, we will get a warning message like in the screen. However, we can execute the pipeline for demo purposes. Click on the Build Now. Verify the console output. We can see the script execution completing successfully. Creating scripts. Let's go step by step and learn how we can create a script. To make things easier, refer to the pipeline DSL reference or use Snippet Generator. Select the checkbox and then select a sample step. Provide specific parameters required by the step and click on Generate Groovy. Creating a Groovy script to build a job. Here's how to create a Groovy script to build a job. It triggers a new downstream job to build. Build a job. Project to build, Pet Clinic-compile. Parameters, none. Other configurations, default. Creating a build step to publish test reports. Creating a build step is used to configure post-build actions or in general build steps that are pipeline compatible based on the drop-down list. Step, general build setup. Build step, publish JUnit test result report. Test report XMLs. Target, surefire-report, test.xml. Other configurations, default. Archiving build job artifacts. To archive build job artifacts, use these parameters. Archive artifacts. This includes artifacts using a comma-separated list matching Ant style pattern for archiving artifacts. This excludes artifacts using a comma-separated list matching Ant style pattern for not archiving artifacts. Running a build step on a node. To run a build step on a specific node, we need to write a script. use Snippet Generator and select the sample step node and select the slave node label. Then click on Generate Groovy. Node, Allocate Node, Label, the label associated with slave node. For more details on master slave nodes in Jenkins 2. Marking the definite steps of a build job. We will now create a Groovy script to mark definite sections of a build job as being controlled by limited concurrency. Stage, stage, stage name, compile, test, or deploy. Other configurations, default. Awesome! We have successfully created a built-in delivery pipeline. In the next video, we will learn how to create a pipeline for compiling and executing test units. Hi again, and welcome to the next video of the third section, creating a pipeline for compiling and executing test units. In the previous video, we have created built-in delivery pipelines. In this video, we will learn how to create a pipeline for compiling source files and executing unit test cases. Let's use this script in the script box. Click on Build Now and go to the console output to verify the execution process. Go to the Build Jobs main page. We can see Stage View here. Remember, we have created two stages. One is compile and the other is test. Stage View provides instant visualization. It provides details such as build completion time, the node on which the build has been executed, and whether the build has executed successfully or failed. For a particular build execution, we can verify pipeline steps as well. Click on Full Stage View to get a full screen view. To obtain details specific to a stage, mouse over a specific stage and it will show you the status of that stage's execution as well as the logs link. Click on the Stage Logs link and it will provide log details respective to the stage. Click on the drop down to obtain more details about the logs. Now, let's consider a scenario where we want to execute different stages on different nodes. Copy this code and paste it in script section. Click on Build Now and verify the stage view. Pipeline steps describes drill down details of execution. Let's verify stage logs for Git operation. Mouse over the compile stage and click on Logs. Expand the Git drop-down like in the screen. Can you guess what could be the potential issue with the Groovy script for creating pipeline? Yes, again, it is code. It becomes difficult to manage it over time, and hence it is always better to store it in a repository. In the pipeline definition section, there is an option to load the pipeline script from SCM. We can select Git or Subversion for the SCM, and then we need to provide repository details and script file details. Awesome! We have successfully created a pipeline for compiling and executing test units. In the next video, we will learn how to use Build Pipeline plugin. Welcome to the next video of Section 3, using the Build Pipeline plugin. In the previous video, we have created a pipeline for compiling and executing test units. In this video, we will learn how to use the Build Pipeline plugin. We have seen the built-in pipeline concept of Jenkins 2. It is a very flexible and powerful concept, but for that, we need to write a Groovy script. Another way that is an easy learning curve is to use the Build Pipeline plugin. It provides simple visualization of upstream and downstream build jobs. It also enables manual triggers for a situation where we need approval for executing a specific build. We can create a chain of jobs for end-to-end automation. Here, I'm assuming that you're aware of the concept of upstream and downstream build jobs. To create a build pipeline, we will use a few steps. First, install the Build Pipeline plugin. On the Jenkins dashboard, click on the plus sign, which will open a page to create a build pipeline view. Provide a view name for the build pipeline and click on OK. It is important to configure upstream and downstream build jobs. We've created multiple build jobs to compile the source code. Verify the source code using Sonar and to execute JUnit test cases. We've defined the order as well. If compilation is successful, the other two build jobs will be executed. In our case, they are petclinic-code and petclinic-test. We will configure the build jobs by using some steps. Go to the configuration page of the petclinic-compile build job. Then, go to the post-build actions section. Enter the name of the build jobs in the project to build text box. You can provide a comma-separated list here. Click on Save to save the configuration. Verify the list of the downstream projects on the build jobs main page. The next step is to configure the build pipeline view we created earlier. Name, the name of the build pipeline. Description, the description is displayed on the build pipeline view page. It can be used to display details such as the pipeline, resources, the objective of the pipeline, and the flow. Filter build queue. Only jobs in this specific view will be shown in the queue. Filter build executors. This is used to show build executors that could execute the jobs in this view. Build pipeline view title. The build pipeline view title to display on the Jenkins dashboard. Layout based on the upstream or downstream relationship. This layout mode derives the pipeline structure based on the upstream or downstream trigger relationship between jobs. Select initial job. This sets the initial or parent job in the build pipeline view. The rest of the build job will be considered based on the upstream or downstream relationship. Number of displayed builds. The number of build pipelines to display in the view. Restrict triggers to most recent successful builds. This is used to restrict the display of a trigger button to only the most recent successful build pipelines. Always allow manual trigger on pipeline steps. This is used to execute a successful pipeline step again, using the same parameter values if the build is parameterized. Show pipeline project headers. This is used to show the pipeline definition header in the pipeline view. Show pipeline parameters in project headers. This is used to list the parameters used to run the latest successful job in the pipeline's project headers. Show pipeline parameters in revision box. This is used to list the parameters used to run the first job in each pipeline's revision box. Refresh frequency in seconds. This provides the frequency in seconds with which the build pipeline plugin updates the build lightbox. URL for custom CSS files. Used for a custom CSS file, if any. Console output link style. You can choose from Lightbox, New Window, or this window. We have selected the petclinic-compile build job in the Select Initial Jobs section as the initial job, as you can see in the screen. On the petclinic-build-pipeline-view page, we can run the build pipeline by clicking on Run. View the history by clicking on History. Configure the pipeline by clicking on Configure, and delete the pipeline by using Delete. Click on Run to execute the build pipeline for the first time. Red indicates failed execution of a build job. Green indicates successful execution of a build job. Blue indicates a build job that hasn't been executed. Yellow indicates a running build job. Now, let's observe the execution of a build job in this pipeline. We can see all jobs in green as all the builds have been executed successfully. Manual trigger configuration makes sure that pipeline step doesn't execute automatically and requires manual intervention to execute next step. It can be very useful in the scenarios where you need to wait for the deployment in the specific environment or to wait for permission before deployment. Let's configure the build pipeline using a manual trigger. Select Yes for all the options. Let's save and verify the changes in the build pipeline view section. Verify the manual trigger and headers with the health details of each build job. Verify the build history of petclinic-build-pipeline-view. Deploying a WAR file. The most important thing in application lifecycle management is the deployment of the packages. That is the business part of the whole exercise. The objective is to automate the process of deployment of the packages into web server or application server. Once the deployment process is automated, it can be easily integrated into end-to-end automation of application delivery. For Maven and Tomcat integration, let's create an admin user. We will use admin user credentials to deploy an application to a Tomcat server. Open Apache tomcat.xml and add these statements into it. Here we define roles such as manager-GUI, manager-script. For this deployment we will use manager-script role. Create a user with the name admin and assign a password and roles. Now we need to add this Tomcat admin user to the Maven settings.xml file. Now let's edit the pom.xml file. Find the Tomcat plugin block in pom.xml. Make sure that the server name is the same one we provided in the settings.xml file of Maven as ID. We can verify execution from the command line using this command. Maven will deploy the WAR file to the Tomcat 7 using the manager app at localhost to the pet clinic path. In the case of any failures because of pre-existing WAR file in the Tomcat web apps folder, use Tomcat 7:redeploy. Let's create a build job in Jenkins and add a build step to invoke top-level Maven targets. Use Tomcat 7:redeploy for goals and save it. Execute the build by clicking on Build Now. Verify the deployment process in the console output. Once the WAR file has been uploaded, the build job will be completed successfully. When we use Tomcat 7:deploy or Tomcat 7:redeploy, it includes the package lifecycle in the execution. If we want to only deploy the WAR file, we can use Tomcat 7:deploy-only. Awesome! In this video we have successfully learned how to use the build pipeline plugin. In the next video, we'll learn how to integrate the deployment operation. Welcome to the last video of section 3. Integrating the deployment operations. In the previous video, we have learned how to use the build pipeline plugin. In this video, we will learn how to integrate the deployment operations. Till now, we have covered pipeline or orchestration of different tasks, and now let's integrate pipeline and deployment automation. By doing this, we will complete continuous integration and continuous delivery with orchestration. Let's try to integrate the deployment operation into the build pipeline. Compile source files.
Execute JUnit test cases. Archive the artifact-war file. It is used to archive build artifacts such as jar files, war files, and zip files, so they can be downloaded later. Add post-build actions to pet-clinic-test to archive the artifact. Execute the build job and verify whether it has been successfully archived or not. If you see finished success, then the build job was successfully executed. We need to add a build step to copy artifacts from pet-clinic-test. Check the Copy Artifact plugin checkbox, and then click on Install without restart. Configure the Copy Artifact plugin in the pet-clinic-deploy build job. Verify the workspace directory. Go to the pet-clinic-test target directory. If a war file is there from a past build, remove it. Verify the target directory of the pet-clinic-deploy folder. There is no war file. Add pet-clinic-deploy as a downstream project to pet-clinic-test. Then, run the build pipeline. Verify the execution of the build pipeline. Click on the lightbox of any build job in the build pipeline. Verify the pet-clinic-test console output. Now, we will copy the archive file from one build and use it for deployment in another build. Once pet-clinic-test build job execution has completed, verify the target folder in the workspace. You will see the war file in the target directory. Verify the execution of the pet-clinic-deploy build job. Verify the build job status in the Jenkins dashboard. Click on the lightbox of Build Pipeline View. It will redirect you to the console output of a specific build job. Click on the pet-clinic-deploy lightbox. Verify the console output. Verify that the successfully uploaded file adheres to the configuration. Good job! We have successfully integrated the deployment operation. This video concludes the third section of this course. In this section, we covered one of the latest features of Jenkins 2 and one of its highlights, built-in support for delivery pipelines. We learned how to use it in detail. We covered a simple groovy script to build a job, generate a build step, archive build job artifacts, run a build step on a specific node, mark definite sections of a build as being controlled by limited concurrency, and so on. We walked through a scenario where we want to execute different stages on different nodes. Another similar plugin was installed and configured with an example, the Build Pipeline plugin. In the next section, we will discuss one of the important pillars of DevOps, culture configuration management using Chef. First, we will see how to install Chef on a workstation and configure it with hosted Chef. We will look at installing Tomcat using Community Tomcat installation cookbooks. Hi, and welcome to the fourth section of this course, installing and configuring Chef. This section describes in detail the configuration management tool Chef, the installation of its components and alternatives, and the configuration of components and convergence of a node for preparing a runtime environment for for Java EE applications using cookbooks. However, writing a cookbook and a detailed discussion of Chef components is out of scope of this section, as it will take up too much space. The section will demonstrate the following topics: getting started with Chef, an overview of hosted Chef, installing and configuring a Chef workstation, converging a Chef node using a Chef workstation. Now we will see the first video of section 4, getting started with Chef. In this video, we will learn the basics of Chef. The Chef is one of the most popular configuration tools in the open source world. Let's get hands-on with provisioning instances and configuration management. However, before that, we will need to understand the basics. There are three major components of Chef: the open source Chef server or hosted Chef, Chef workstations, node. The open source Chef server or hosted Chef. The Chef server or hosted Chef is the pivotal component which stores cookbooks and other important details of registered nodes. It is used to configure and manage nodes using Chef workstations. Chef workstations. A Chef workstation works as a local repository, and the Knife plugin is installed on it. Knife is used to upload cookbooks to the Chef server and execute plugin commands. Node. A node is a physical or virtual machine in any environment where we need to configure runtime environments or perform operations using Chef configuration. The node communicates with the Chef server, open source or hosted, obtains configuration details related to itself, and then starts executing steps based on it. The Chef server can be installed on a physical machine or a virtual machine with an open source installable file based on the operating system. Another, easier method to use is hosted Chef, where we need not install and configure a Chef server. We can use the SaaS offering from Chef. It allows up to 5 nodes. The biggest benefit is we need not manage a Chef server or upgrade it. Hence, we save ourselves from management and maintenance overhead. Take a look at the Chef website. You will see the Chef homepage like this. There are a lot of details available here about Chef and cloud-related integration, as well as Knife plugins. We will create a hosted Chef account in the next section and configure it with a local workstation. To proceed, click on the Management Console link in the top right corner of the Chef website. Now that we know the basics of Chef, in the next one, we'll learn the overview of hosted Chef. Hi again, and welcome to the next video of the 4th section, Overview of Hosted Chef. In the previous video, we have learned the basics of Chef. In this video, we will learn the overview of hosted Chef. We can use Chef server either by installing and managing Chef server on our own, or we can use hosted Chef SaaS offering to utilize in configuration management. Click on Management Console. As we are going to start from scratch, click here to get started. Enter your full name, company name, email address, and username in the respective text boxes, and check the box that says I agree to the terms and conditions and master license and services agreement. Then click on the Get Started button. Open your email inbox and click on the verification link to complete the creation of your hosted Chef account. You will get an email verification successful message. After typing your password, click on Create User button. The next task is to create an organization. Click on Create New Organization. Provide the full name and short name of the organization and click on the Create Organization button. Bingo! You have just created your hosted Chef account and you can now start using it. The next step is to download a starter kit. When you click on Download Starter Kit, your user and organization keys will be reset. Make sure to keep them in a safe place. On the confirmation dialog, click on Proceed. Let's have a quick walkthrough of the hosted Chef portal or dashboard. Click on Nodes. you'll be shown an empty list as no node has been configured using the chef server. Note this as we are going to see the same screen when we configure a node later. Now, navigate to Administration-Users and verify the user account created at the time of registration. The Reports tab has no data as the convergence process hasn't taken place and no successful or failure data is available. Once we have a hosted chef account available, the next step is to configure a chef workstation. First, download the Red Hat version of the chef client as we're going to use a CentOS virtual machine to act as our workstation. Select your operating system type, select the chef client version, and download the installation files. The Chef Development Kit is useful for installing development tools, and it can also be used to install Knife plugins for AWS and Azure. Download it from here. Awesome! We have successfully learned about Hosted Chef. In the next video, we will see how to configure a Chef workstation. Welcome to the next video of Section 4, Installing and Configuring a Chef Workstation. In the previous video, we have learned the overview of Hosted Chef. In this video, we will learn how to install and configure a Chef workstation. Before installing a Chef client for preparing a workstation, let's try to verify whether the Chef client has been installed. Execute the Chef client version command to verify whether the Chef client has been installed. As you can see in the output of the previous command, the Chef client is not installed. Now, navigate to the directory where the Chef client installable is stored using the cd command. Run the downloaded Chef client RPM using this command. Permission is denied, so we use sudo to run the command and verify the installation process. After successful installation, verify the Chef client version. The next step is to use the Chef starter kit that we downloaded while creating an account in Hosted Chef. Extract the chef-repo compressed file and verify its contents. Copy the .chef directory into the root or user folder. Verify the cookbooks folder available in the chef-repo directory. In the .chef directory, open the knife.rb file, which contains various configurations. All the configurations you need are already available. Adjust the path of the cookbooks directory if needed. Excellent! We have finished configuring our Chef workstation. In the next video, we'll learn how to converge the node. Welcome to the next video of Section 4, Converging a Chef node using a Chef workstation. In the previous video, we've installed and configured a Chef workstation. In this video, we will try to set up runtime environment in Node using Chef workstation. First of all, let's log into the Chef workstation which set up. Open the terminal and verify the IP address using ifconfig. Verify the Knife version installed on the Chef workstation with knife-version. The knife node list command is used to obtain the list of nodes served by the Chef server, in our case, Hosted Chef. As we haven't converged any nodes, the list will be empty. Create a virtual machine using VMware Workstation or VirtualBox. Install CentOS. Once the VM is ready, find its IP address and note it down. On your Chef workstation, open a terminal and, using SSH, try to connect to the node or VM we just created. The authenticity of the local host can't be established. We now have an SSH session on the node from the Chef workstation. If you verify the IP address, you'll know that you are accessing a different machine by remote SSH access. Let's verify the node virtual machine. In my case, the VM already had the Chef client installed, so execute this command and see what result we will get. Let's remove the Chef client installation using this command. We've removed the Chef client. To verify this, execute this command. Let's remove the Tomcat installation as well, if it has been installed on the node. Now, run the yum remove tomcat 6 command to verify whether Tomcat is still installed on the system. Check whether the Java Development Kit, JDK, has been installed on the node. Exit the SSH session of the node's virtual machine. We now have control of the Chef workstation machine, and we will try to converge the node VM we just accessed remotely. Use knife to converge the node. Provide the IP address, DNS name, user, password, and name of the node. Verify the output. There was no run list or role associated with the knife command, but the convergence was successful. Let's verify our hosted Chef account. We can see the node name and IP address in the node section of dashboard, so open it and verify the details. Select a node and click on the Details tab to get more information about the node, such as the attributes associated with it and its permissions, as like in the screen. Verify the CPU attributes and other details of the node. The convergence was successful, and we can see that in the report section of the hosted Chef account. Great work! We have successfully converged a Chef node using a Chef workstation. In the next video, we will learn how to install software packages using cookbooks. Welcome to the next video of Section 4, Installing Software Packages Using Cookbooks. In the previous video, we have converged a Chef node using a Chef workstation. In this video, we will see how to install software packages using cookbooks. To set up the runtime environment automatically, it's best to use the Chef Community Cookbooks. Visit this site and find all the community cookbooks required to set up a runtime environment. We are using a sample Spring application, namely Pet Clinic. We need to install Java and Tomcat to run a Java EE application such as this. Download the Tomcat cookbook from this site and navigate to the dependencies section on that page. Without the dependencies uploaded to our Chef server, we can't upload the Tomcat cookbook to use it. Download OpenSSL and Chef Sugar from these sites. To install Java, download the cookbook from this site and its dependency from here. Extract all compressed files to the cookbooks directory. Go to cookbooks from the terminal and verify the subdirectories onto the community cookbooks. Upload the apt cookbook with knife cookbook upload apt command. Verify from the cookbook section on the hosted Chef instance whether the apt cookbook has been uploaded. Make sure to upload all dependencies first, or it will give you an error. Upload all other cookbooks in order. Check whether all the cookbooks have been uploaded from the hosted Chef account. Great work! We've successfully installed software packages using cookbooks. In the next video, we will learn how to create a role. Welcome to the last video of section 4, creating a role. In the previous video, we've installed software packages using cookbooks. In this video, we will learn to create a role. Once all cookbooks have been uploaded successfully, we need to create a role. A role is defined for a specific function and provides a path for different patterns and workflow processes. For example, the web server role can consist of Tomcat server recipes and any custom attributes. Go to Policy, Roles, Create to create a role. In the Create Role window, provide a name and description. And then click on Next, as in the screen. A run list keeps roles in a proper manner and order. We can say that it describes the specifications of a node. Select Tomcat from the Available Recipes section, drag it to the current run list section, and click on Create Role. Verify the newly added role details in the Hosted Chef dashboard. Now, we are ready to associate the role while converging the node. Add the role to the node with this command. The role has now been associated with the node, and the next time the chef client runs on the node, it will check whether it is in sync with its assignment. If not, it will execute the steps to bring the status in compliance with the role assigned. If you take a look at the output, we will come to know what exactly happens when convergence takes place. Verify the Reports section in the Hosted Chef account to obtain the latest details. Now we know how to create a Hosted Chef account, configure a workstation, and converge a node. This is the important piece in the end-to-end automation, as with the use of Chef Configuration Management tool, we have set a runtime environment that is required to run Java EE application. Good job! We've successfully created a role. This video concludes the fourth section of this course. In this section, we covered how we can create a Hosted Chef account, configure a workstation, upload a community cookbook to a Hosted Chef account, converge a node, use community cookbooks to install Tomcat, verify the convergence of a node on a Hosted Chef account, and verify success and failure reports. Essentially, we are standardizing the process of setting up a runtime environment from a centralized location. Most of the configuration tools do almost similar things, and you can decide based on experience and other features which configuration management tool you want. Automating the repetitive process in any field is the key to increasing efficiency, and configuration management tools do exactly that in the end-to-end automation of application delivery. In this section, we automated installing Tomcat and other runtime requirements for sample Java EE application, so we can deploy the WAR file created by continuous integration process. In the next section, we will discuss Docker, one of the most popular technologies in recent times. It is also one of the most disruptive innovations. We will see how Docker containers are different from virtual machines, how to install them, and some basics about the technology. Hi, and welcome to the fifth section of this course, understanding the difference between virtual machines and containers. This section will describe container technology in detail and explain how it is different from virtual machines by comparing the benefits of both. It will give you an overview of Docker and its installation and configuration details. It will also cover how to create CentOS containers for application deployment. We will also cover Docker Hub and the basic architecture of Docker. We will see how to use the Tomcat image available on Docker Hub and create a sample image with a Java and Tomcat installation and a Docker file. The section will demonstrate the following topics: overview of Docker containers,
understanding the difference between virtual machines and containers, installation and configuration of Docker on CentOS, creating your first Docker container, managing containers. Now we will see the first video of Section 5, understanding the difference between virtual machines and containers. In this video, we will know the difference between virtual machines and containers. Docker is an open source initiative for OS virtualization that automates the deployment of applications inside software containers. It provides isolated user spaces and hence provides user-based processes, space, and file systems. Behind the scenes, it shares the Linux host kernel. This structure will illustrate the working mechanism of a Docker container. Docker has two main components, with a client-server architecture. The Docker host. The Docker host contains the Docker daemon, containers, and images. The Docker engine is an important component that provides the core Docker technology. This core Docker technology enables images and containers. When we install Docker successfully, we run a simple command. In our case, we will consider CentOS for the container. To run an interactive shell in the CentOS image, use this command. The -i flag initiates an interactive container. The -t flag creates a pseudo terminal that attaches standard input and standard output. The image is a CentOS image. /bin/bash starts a shell. When we run this command, it verifies whether the CentOS image is available locally. If it is not available, it will download the image from Docker Hub. An image has a file system and parameter that can be used at runtime, while a container is an instance of an image with a state. It is simple to understand that containers change while images do not. Docker Hub. Docker Hub is a software as a service, SaaS, for sharing and managing Docker containers. It is a kind of centralized registry service provided by Docker. As a user, we can use it to build and ship applications. It allows us to create a pipeline to integrate with code repositories and for collaboration, image discovery, and automation. Let's navigate to this site and sign up by providing a username, email, and password. Activate your account by clicking on the activation link sent to your email ID. After successful activation, log in to your Docker Hub account. The Docker dashboard will look like this. Click on repositories to find images available in the public domain. Search for CentOS and you will get a list of all CentOS images available on Docker Hub. In recent times, cloud computing has become part of almost all technical discussions. Virtual machines have served a lot of people in utilizing resources efficiently. However, Docker containers have given them competition and, in fact, containers are more effective. Let's find out the basic differences between both the virtual machines and containers to find out the reason behind the popularity of containers. Virtual machines. In the virtual machine, we need to install an operating system with the appropriate device drivers. Hence, the footprint or size of a virtual machine is huge. A normal VM with Tomcat and Java installed may take up to 10 GB of drive space. There's an overhead of memory management and device drivers. A VM has all the components a normal physical machine has in terms of operation. In a VM, the hypervisor abstracts resources. In a VM, the package includes not only the application, but also the necessary binaries and libraries, and an entire guest operating system. For example, CentOS 6.7 and Windows 2003. Cloud service providers use a hypervisor to provide a standard runtime environment for VMs. Hypervisors come in Type 1 and Type 2 categories. Containers. A container shares the operating system and device drivers of the host. Containers are created from images, and for a container with Tomcat installed, the size is less than 500 megabytes. Containers are small in size and hence effectively give faster and better performance.
Containers abstract the operating system. A container runs as an isolated user space, with processes and file system in the user space on the host operating system itself, and it shares the kernel with other containers. Sharing and resource utilization are at their best in containers, and more resources are available due to less overhead. It works with very few required resources. Docker makes it efficient and easier to port applications across environments. Now that we know the differences between virtual machines and containers, in the next one, we'll learn how to install and configure Docker on CentOS. Hi again, and welcome to the next video of the 5th section, installing and configuring Docker on CentOS. In the previous video, we have learned the difference between virtual machines and containers. In this video, we will create a virtual machine using VMware, Workstation or VirtualBox. Install CentOS 7. We will use few steps to use CentOS 7 to run Docker. In CentOS 6.x, there was a minor issue of a package name conflict with a system tray application and its executable. So the Docker RPM package was called docker-io. Let's install docker-io. Let's try to run the sample hello-world image of Docker. The sample image execution didn't complete successfully, as the Docker service wasn't running. Let's verify the Docker installation. First, start the Docker service. Verify the status of the Docker service. So we have now successfully installed Docker and verified whether its services are running on a CentOS 7 virtual machine. Awesome! We have successfully installed and configured Docker on CentOS. In the next video, we will learn how to create your first Docker container. Welcome to the next video of section 5, creating your first Docker container. In the previous video, we have learned how to install and configure Docker on CentOS. In this video, we will learn how to create the first Docker container. Just to get a feel of Docker, let's run a sample hello world container, which we tried to do earlier without success. The hello world image is not available locally, so it will be fetched from Docker Hub. This message shows that your installation appears to be working correctly. To generate this message, Docker performs few steps. The Docker client communicates with the Docker daemon. Then, Docker daemon pulls the hello world image from Docker Hub. After that, the Docker daemon creates a new container from that image, which runs the executable that produces the output you are currently reading. When the executable gets executed in a newly created container, the Docker daemon streams that output to the Docker client, which sends it to your terminal. Let's try something more ambitious. You can run an Ubuntu container with this command. Now we have one image available locally. Let's try to create an Ubuntu container and open its bash shell directly. Use the Docker images command to verify that the existing images are available locally. After these two examples, let's try to understand the client-server architecture of Docker using another example of a Tomcat container. Awesome! In this video, we have successfully created your first Docker container. In the next video, we'll understand the client-server architecture of Docker. Welcome to the next video of section 5. Understanding the client-server architecture. In the previous video, we have created your first Docker container. In this video, we will know about the client-server architecture of Docker. Let's recollect our main objective. We want to deploy a sample Spring application named pet-clinic on our Tomcat server. How is it different when we install Tomcat in the virtual machine and use containers? In container environment, host OS is installed, and then it is used the host container layer. Container layer is used for provisioning container instances. Container instances are extremely lightweight and efficient, as extra libraries or resources are needed for the operating system that is needed in the virtual machine, while not in case of containers. For that, in the rest of the section, we will try to use the existing Tomcat image and also create a sample image with a Tomcat installation. Navigate to this site, and after you log in, search for Tomcat in the search section. Click on Tomcat, and you will be presented with something like this. Verify the images with Docker images, and then try to run the Tomcat image. It will take a while. Once image is pulled completely, the container will be created and the bash shell will be available for command execution. The container is created successfully. Verify existing containers using the docker ps command. Once we have the Tomcat container ready, let's try to find out its IP address so we can access Tomcat using it. Use docker inspect with the container ID to find out the IP address of the container. Docker networking is a different concept itself and is not in the scope of this video course, so we are not going to cover it. However, let's verify whether the Tomcat container is running properly. So finally, we are able to run a Tomcat container. Great work! We have successfully learned about the client-server architecture of Docker. In the next video, we will try to cover some basic but useful commands and try to build an image. Welcome to the next video of Section 5, Managing Containers. In the previous video, we have learned about the client-server architecture of Docker. In this video, we will try to run the Tomcat container as a background process. It is best practice to run a Docker container as a background process to avoid accidentally stopping containers from the terminal. Use the -d parameter. Verify the container you just created. Get the IP address of the container with the docker inspect command along with the container ID. Note this IP address and try to access it from the browser. Now the obvious question is how to stop containers, right? To obtain the details of running containers, use docker ps. Observe the last column, names. You can see a strange name, desperate_hypatia, being automatically allocated to a container if it is not given a name explicitly. Let's stop the container using this automatically assigned container name. If we want to provide a custom name to the container, then we can rename it using the ---- name operator, as we can see in this command. Can we see the list of all containers that have been stopped? Yes. Use the docker ps-a command to get a list of stopped containers. A container's lifetime is limited to the existence of a parent process. To get access to a terminal on the container, use this command after creating the container. Once you have access to the container console, verify its IP address using this command. Now, let's try to search for the Tomcat images available on Docker Hub. try docker search tomcat command. Let's verify the existing images again. Great work! We've successfully managed containers. In the next video, we will learn how to create a Docker image from Docker file. Welcome to the last video of section 5, creating a Docker image from Docker file. In the previous video, we have learned how to manage containers. In this video, we will learn to create a sample image file, and we will build a Docker image using a Docker file. Let's try with a simple CentOS image. The Docker file contains these two lines. Go to the same directory in the terminal and use docker build to build an image. We've successfully built a sample Docker image. Now, let's verify it by executing this command. Now, we will create an image with Java 8 and Tomcat 9 to understand how we can create a sample image. Verify whether you have 32 or 64-bit operating system. Based on that, we will download the respective installable files. We have a 64-bit operating system, so for Java, we will use the 64-bit installer. The download URL for Java from this site. Download Tomcat from this site. For a Java and Tomcat installation, we have these Docker files. Let's run the Docker file and build an image out of it. Good job! We've successfully built a sample image using a Docker file. This was just a quick example to get started and familiar with Docker and its concepts. This video concludes the 5th section of this course. In this section, we had an overview of Docker containers, architecture details, and details of the main components of Docker, including a quick overview of Docker Hub. Based on the overview, we try to compare virtual machines with Docker containers to gain a clear picture of why containers have recently been gaining traction. After gaining some understanding of virtual machines and containers, we covered the process of installing Docker on a CentOS 6.x virtual machine. We created a hello-world container and Ubuntu and CentOS containers from the images available on Docker Hub. Our main aim is to use a Tomcat container for deploying a sample Spring application. So we used a Tomcat image and created a container from it for verification. To gain more understanding, we used a Docker file to build an image with Java and Tomcat. In the next section, we will see how to use Chef to create a virtual machine in Amazon Web Services and Microsoft Azure and set up a runtime environment.
Hi, and welcome to the 6th section of this course, Cloud Provisioning and Configuration Management with Chef. This section will describe in detail how to install knife plugins used to manage cloud resources using Chef. It will cover creating instances in AWS and Azure using the Knife EC2 and Knife Azure plugins. It will also cover how Chef is used to manage Docker containers. The section will demonstrate the following topics: Chef and cloud provisioning, installing Knife plugins for Amazon EC2 and Microsoft Azure, creating and configuring a virtual machine in Amazon Web Services, creating and configuring a virtual machine in Microsoft Azure, managing Docker containers with Chef. Now we will see the first video of section 6, Chef and cloud provisioning. In this video, we will focus on infrastructure provisioning in cloud environment and setting up runtime environment. Chef is not only used for setting up runtime environments or configuration management, but it is also used for resource provisioning in cloud environments. It supports cloud service providers such as Microsoft Azure, Amazon Web Services, VMware, OpenStack, HP Cloud, and Google Compute Engine. Chef provides more flexibility to the concept of infrastructure as a code and brings configuration management into the picture as well. Knife plugins are used to manage or use different cloud service providers. With Knife plugins, it is easier to provision and deprovision resources along with controlled and centralized configuration management. The infrastructure provisioning in cloud environment and setting up runtime environment will look like this structure. We will specifically focus on infrastructure provisioning in a cloud environment and setting up a runtime environment with a configuration management tool. We will provision resources in a public cloud environment using Knife plugins using a Chef workstation. We configured a Chef workstation in section 4, installing and configuring Chef. From the Chef workstation, we can execute Knife commands to create instances, Chef nodes, in different cloud environments. In our case, we will provision resources in Amazon EC2 and Microsoft Azure. This is how the process will work. Chef workstation to CSP. Create a new instance in your cloud environment. CSP. OK, done. The new instance is up and running. The Chef node is available. Chef node to Chef server. Hello? Chef server to Chef node. Here is your task. Download the Chef client. Chef server and Chef node interaction. A secure handshake is made. The Chef server generates a security certificate. The security certificate is used to authenticate the new node's upcoming requests. Chef server to Chef node. Here's the list of recipes you need to install. Chef node to Chef server. Thank you, I've been updated. Some of the major benefits we get through using Chef with different cloud platforms are: easy policy enforcement with centralized control, setup of a consistent runtime environment, building a repeatable infrastructure to avoid manual effort and errors, rapid deployment of new applications, easy restoration of environments, disaster recovery and business continuity, community-based cookbooks and recipes, faster time to market to remain in competition, support for major cloud service providers through plugins. Now that we have successfully learned about Chef and cloud provisioning, in the next video we will install Knife plugins for some popular cloud platforms. Hi again, and welcome to the next video of the 6th section, installing Knife plugins for Amazon Web Services and Microsoft Azure. In the previous video, we have learned about Chef and cloud provisioning. In this video, we will learn how to install Knife plugins for Amazon Web Services and Microsoft Azure. The Chef development kit, Chef DK, comes with development tools built by the Chef community. It makes the task of installing knife plugins easier. Go to this site and download the Chef DK for our platform. For our purposes, select Red Hat Enterprise Linux and select the version. Click on the Chef DK 1.0.3 folder, and then we will install it by using this rpm command. Once we have the Chef DK installed, we can use chef gem install knife ec2 to create, bootstrap and manage ec2 instances. It is available at this site. Now we will install knife using this command. Once knife ec2 has been installed successfully, we should verify the available ec2 commands. We can configure Amazon EC2 credentials for knife EC2 in the knife.rb file using knife AWS_access_key_ID and knife AWS_secret_access_key, like this. Once we have the Chef DK installed, we can use the Chef gem install knife Azure plugin, which is used to create, delete, and enumerate Microsoft Azure resources to be managed by Chef. The Chef Knife plugin for Microsoft Azure is available at this site. Now we will install the Knife Azure version 1.5.2 by using this command. Once Knife Azure has been installed successfully, we should verify the available Azure commands using Knife Azure help command. Chef Knife has support for VMware Workstation and allows deployment against a workstation. It is available at this site. Now we will install Knife WS Fusion by using this command. Once Knife WS Fusion has been installed successfully, verify its available commands by using Knife WS Fusion help command. Awesome! We've successfully installed the Knife plugins required for AWS and Microsoft Azure. In the next video, we will try to create a virtual machine using Amazon EC2. Welcome to the next video of Section 6, Creating and Configuring a Virtual Machine in Amazon EC2. In the previous video, we have learned how to install Knife plugins for Amazon Web Services of Microsoft Azure. In this video, we will learn how to create and configure a virtual machine in Amazon EC2. Before creating and configuring a virtual machine in Amazon EC2, let's verify the existing nodes converged by Chef. Local virtual machines are only configured using Chef. Now we will install EC2 Server plugin. After installing Knife EC2 plugin, we can use Knife EC2 Server create command with few parameters to create new virtual machine. Parameter and description. ID of the Amazon machine image. F. Type of virtual machine. N. Name of the Chef node. AWS access key ID. ID AWS account access key ID. AWS secret access key. AWS account secret access key. S. SSH key. Identity file. PEM file. SSH user. User for AWS instance. R. Chef role. At this stage, the AWS EC2 instance has been created and is waiting for SSHD access to become available. It will take some time to install. At this stage, the Chef client has been installed on the AWS instance. It is ready for the initial Chef client run with version. It is now ready to resolve cookbooks based on the role and install runtime environments. Our runtime environment is set up, and now it is time to start Tomcat services in our AWS instance. Here are the details of the newly created AWS instance. Now, go to this site and log in with admin or Identity and Access Management (IAM) credentials. Click on Instances in the left-hand sidebar or on Running Instances on the Resources page. Get to the details about AWS instances. Verify the name, tags, public DNS, and other details that we get in the Chef client run. Now, let's go to the hosted Chef dashboard and log in. Click on Nodes and verify the newly created or converged node. Verify the instance details and run list. Check the Attributes section in the hosted Chef dashboard. Everything seems to be nicely done with regard to the creation and configuration of the AWS instance and its registration on hosted Chef. The reason for this is the restriction of security groups in AWS. Verify the security groups the AWS instance belongs to. Go to the Security Groups section from the AWS dashboard, select the default security group and verify the inbound rules. We can see only the SSH rule available. Let's create a new custom TCP rule with port 8080 and save it. Awesome! In this video, we've successfully created and configured a virtual machine in Amazon EC2. In the next video, we will see how to create and configure a virtual machine in Microsoft Azure. Welcome to the next video of Section 6, Creating and Configuring a Virtual Machine in Microsoft Azure. In the previous video, we have created and configured a virtual machine in Amazon EC2. In this video, we will learn how to create and configure a virtual machine in Microsoft Azure. For the Knife Azure plugin to communicate with Azure's REST API, we need to provide information to the Knife regarding our Azure account and credentials. Sign in into the Azure portal and download a published settings file by visiting at this site. Store it on a Chef workstation on a local file system and refer to this local file by creating an entry in knife.rb. Here are the parameters used to create a virtual machine in Microsoft Azure. Parameter and description. Azure-DNS-name. DNS name. Azure-VM-name. Virtual machine name. Azure-VM-size. Virtual machine size. N. Name of the Chef node. Azure-storage-account. Azure storage account. Bootstrap-protocol. Bootstrap protocol. Azure-source-image. Name of the Azure source image. Azure-service-location. Azure location to host virtual machine. SSH-user. SSH user. SSH-password. SSH password. R. Role. SSH-port. SSH port. After installing Knife Azure plugin, let's create virtual machine in Microsoft Azure by using Knife Azure Server create command. Go to the hosted Chef portal and click on Nodes to check whether the new node has been registered on the hosted Chef server. Click on the Reports section on the hosted Chef server and verify the graphs for run summary, run durations, and run counts. Now, let's go to the classic Azure portal and click on the Tomcat server virtual machine and verify the status. Click on Virtual Machines in Microsoft Azure and you'll get details about it. We are now close to our main objective, that is, the end-to-end automation of the application deployment pipeline. We have covered continuous integration, cloud provisioning, containers, and configuration management. What's left is the actual deployment, monitoring, and orchestration of all the activities involved in the end-to-end automation. In the next video, we will learn about Docker containers. Welcome to the last video of Section 6, Docker containers. In the previous video, we have created and configured a virtual machine in Microsoft Azure. In this video, we will learn more about Docker containers. Docker containers are extremely lightweight. We are going to use Tomcat as a web application server to deploy the Pet Clinic application. Docker Hub already has the Tomcat image, so we're not going to configure too many things except users for accessing the Tomcat Manager app. To tomcat-users.xml, add a role and user by using this highlighted code. Now, we're going to use the image available in Docker Hub and add tomcat-users.xml to user, local, tomcat, conf, tomcat-users.xml. Create a Docker file by using this command. Once everything is ready, use docker build to build a new image by using the DevOps tomcat new command. The image has been successfully built. Let's verify using Docker images by using the docker image command. Create a container from the newly created Tomcat image. Verify existing containers using docker ps and docker ps-a. Use docker inspect ID to obtain the IP address and browse the Tomcat web server using the IP address and port. Click on the Manager app button. It will ask for a username and password. Type them in and click on OK. Now, we can access the Tomcat Manager application. We can use Tomcat Manager application to deploy applications. Until now, we have looked at continuous integration, configuration management, containers, and cloud provisioning. Next, we will cover application deployment using different methods, monitoring, and end-to-end automation pipeline using orchestration. Good job! We've successfully learned about Docker containers. This video concludes the 6th section of this course. In this section, we covered how to provision resources in the cloud and configure them. We used the Knife EC2 and Knife Azure plugins to create virtual machines in AWS and Microsoft Azure, respectively. We used the Docker Hub Tomcat image to build a new image with a tomcat-users.xml file, which has roles and users configured to access the Tomcat Manager web app. In the next section, we will cover different methods to deploy an application in a Tomcat web container. Let's again reiterate the goal of the video: end-to-end automation using an application deployment pipeline. Welcome to the 7th section of this course, deploying application in AWS, Azure, and Docker. In the previous section, we saw cloud provisioning and configuration management with Chef. In this section, we will cover topics such as prerequisite, deploying our application on a remote server, deploying the application on AWS, deploying the application in a Docker container. Here we are at the first video of this section, prerequisites, deploying our application on remote server. In this video, our aim objective is to deploy Pet Clinic application to a remote Tomcat server. Web server and application server can be on local environment or remote environment. We will first deploy on a remote server. We will try to use Windows agents for compilation and deployment to see how agent-based architecture can be utilized. Follow a few steps to deploy an application on a remote server. First, let's start an agent on a Windows machine. Open Command Prompt and run the command given in the Manage Nodes section of the Jenkins dashboard. Change the URL accordingly. As you can see, we need to run these commands. Note that we need to run these commands on your Windows command prompt, not on CentOS. Our agent is now connected to the master. Let's verify the status of the agent on the master node, where Jenkins is running. Click on the test server agent, and you'll get all the details regarding projects tied to it, as shown here. Now that we have the agent node ready, let's prepare a remote server by downloading and setting up Tomcat. Now, let's set up a Tomcat server. In our case, we do not need to do it for cloud instances, as they will be configured using Chef. We will take a look at a more involved perspective on how we did it earlier and how all of the installation and other activities can be automated using Chef. Let's take a step-by-step tour. Download Tomcat 7 from this link. We're going to use the deploy plugin from Jenkins, and it requires specific versions of Tomcat for deployment. Extract the Tomcat installation files as shown. Open Command Prompt and go to the bin directory to start Tomcat by using this command. Use the proper IP address and port number combination to navigate to the Tomcat homepage, which looks like this. Go to conf and then open tomcat-users.xml in your Tomcat installation directory and uncomment the role and user lines or rewrite them as shown here. Set manager GUI as the role name for testing purposes. We need manager-script for deployment via the deploy plugin. Click on the manager application link on the Tomcat homepage and enter the username and password you set in tomcat-users.xml. Now, we can access the management application. For the Jenkins deploy plugin, change the role name to manager-script. Restart Tomcat and visit this link. You should see this output. Go to the Jenkins job build page and click on Configure. Select the proper JDK configuration for the Jenkins agent, as we have done here. Under Post Build Actions, select Deploy WAR or EAR to a container. Provide the location of the WAR file in the Jenkins workspace, the Tomcat Manager credentials, and the Tomcat URL with the port. Click on Apply and Save. Click on Build Now on the Jenkins Builds page. Verify the console output as showing a fresh deployment. It might take some time. Once the build is successful, visit the URL from your browser and notice the context. It is similar to the name of the application. In Post Build Actions, provide a context path as shown and click on Save. Click on Build Now again. Verify the application URL by providing a new context path. Great! So in this video, we saw how to deploy your application on remote server. In our next video, we will deploy the application in Docker container. Hi, this is the second video of this section, deploying application in Docker container. In our previous video, we saw how to deploy application on remote server. In this video, we will see how to deploy an application with a deploy plugin of Jenkins. We've already covered how to use Tomcat with Docker containers in section 5, installing and configuring Docker. To deploy an application with the deploy plugin of Jenkins, we will modify tomcat-users.xml. Let's take it step by step. Change role name to manager-script in tomcat-users.xml. In the Docker file, we will copy tomcat-users.xml to the user local tomcat conf directory. Execute the docker build command to create an image. Verify the newly created image using the docker images command. Execute docker run to create a container using this command. Verify the new container with the docker ps command. Use docker inspect container ID to get an IP address. Stop the IP tables service for verification or opening ports in IP tables. Use the IP address to access the manager app URL. Verify whether it is successful. As we have mapped the port, use the host's IP address and verify your Tomcat installation. Use the IP address of the host and access the manager app URL. Provide a username and password. Check whether it is successful. Once everything is working fine, use the deploy plugin to deploy an application in a Docker container. Awesome! So this video we deployed application in Docker container. In our next video, we will see how to deploy application in AWS. Hi, this is the third video of this section, deploying application in AWS. In our previous video, we saw how to deploy application in Docker container. In this video, we will deploy the application on AWS Elastic Beanstalk. AWS Elastic Beanstalk is a platform as a service, PaaS, offering from Amazon. We will use it to deploy the Pet Clinic application on the AWS platform. Good part is we need not manage infrastructure or even platform, as it is a PaaS offering. We can configure scaling and other details. These are the steps to deploy an application on AWS Elastic Beanstalk. Elastic Beanstalk supports the following programming languages and platforms. Let's create a sample application to understand how Elastic Beanstalk works, and then use the Jenkins plugin to deploy an application. 1. Go to the AWS Management Console and verify whether we have a default Virtual Private Cloud, VPC. If you've deleted the default VPC and subnet by accident, send a request to AWS Customer Support to recreate it. Click on Services in the AWS Management Console and select AWS Elastic Beanstalk. Create a new application named Pet Clinic. Select Tomcat as a platform and select the Sample Application radio button. Verify the sequence of events for the creation of a sample application. It will take a while, and once the environment has been created, it will be highlighted in green, as shown here. Click on the Pet Clinic environment and verify the health and running version in the dashboard. Verify the environment ID and URL. Click on the URL and verify the default page. Install AWS Elastic Beanstalk Publisher plugin. For more details, visit this link. Open the Jenkins dashboard and go to Build Job. Click on Post Build Actions and select Deploy into AWS Elastic Beanstalk. A new selection will come up in Post Build Actions for Elastic Beanstalk, as you can see here. Click on the Jenkins dashboard and select Credentials. Add your AWS credentials. Go to your Jenkins build and select an AWS credential that is set in the global configuration. Select AWS region from the list and click on Get Available Applications. As we've created a sample application, it will show up like this. In Environment Lookup, provide an environment ID in the Get Environments by Name box and click on Get Available Environments. Save the configuration and click on Build Now. Let's verify the AWS Management Console whether WAR file is being copied in Amazon S3 or not. Go to S3 Services and check the available buckets. Verify the build job's execution status in Jenkins. Some sections of the expected output follow. Since the WAR file is large, it will take a while to upload to Amazon S3. Once it is uploaded, it will be available in the Amazon S3 bucket. The test case execution and WAR file creation are successful. The execution of AWS EB deployment plugin post-build action has been started. The deployment activity with the new version label starts. The environment and health statuses are updated along with the deployment status. The build is successful. Now, check the AWS Management Console. Go to Services, click on AWS Elastic Beanstalk, and verify the environment. The previous version was Sample Application. Now the version is updated as given in version label format in the Jenkins build job configuration. Go to the dashboard and verify health and running version again. Click on the configuration link on the Elastic Beanstalk dashboard and verify scaling, instances, notifications, software configuration, updates and deployments, health, and so on. Click on Logs to download the log files for Elastic Beanstalk. Go to the Enhanced Health overview and check the status. Click on Monitoring for extensive monitoring details in the form of CPU utilization and health of an application. Click on Events to get list of all the events of the Elastic Beanstalk application lifestyle. Once everything has been verified, click on the URL for the environment and our pet clinic application is live. Once the application deployment is successful, terminate the environment. We have thus successfully deployed our application on Elastic Beanstalk. Awesome! So we just deployed our application in AWS. In our next video, we will see how to deploy the application in Microsoft Azure. Hi, this is the fourth video of this section, deploying application in Microsoft Azure. In our previous video, we saw how to deploy application on AWS Elastic Beanstalk. In this video, we will deploy the application on a PaaS model. Microsoft Azure App Services is a PaaS. PaaS. In this video, we will look at the Azure Web App and how we can deploy our Pet Clinic application. Let's install the Publish Over FTP plugin in Jenkins. We will use the Azure Web Apps FTP details to publish the Pet Clinic WAR file shown here. Once the plugin has been installed successfully, restart Jenkins. Go to Microsoft Azure portal at this link. Click on App Services and then on Add. Provide values for app name, subscription, resource group, and app service plan or location. Then click on Create. Once the Azure Web App is created, see whether it shows up in Azure portal. Click on DevOps Pet Clinic to obtain details related to the URL, status, location, and so on. Click on All Settings. Go to the General section and click on Application Settings to configure the Azure Web App for Java Web Application hosting. Select the Java version, Java minor version, Web Container, and Platform, and click on Always On. Visit the URL of an Azure Web App from your browser and verify that it is ready for hosting our sample Spring application, Pet Clinic. Let's go to the Jenkins dashboard. Click on New Item and select Freestyle Project as shown. Copy the general configuration from another build so we don't need to repeat the configuration work in the newly created job. Click on All Settings and go to Deployment Credentials in the Publishing section. Provide a username and password, and save your changes. In Jenkins, go to Manage Jenkins and click on Configure FTP settings as shown. Provide a hostname, username, and password available in Azure portal. Go to this link and download the Kudu console. Navigate to the different options and find the site directory and web apps directory. Enter the details as shown on screen. Copy the host name from here. Click on Test Configuration. And once you get a success message, you are ready to deploy the Pet Clinic application. In the build job we created, go to the Build section and configure Copy Artifacts from another project. We will copy the WAR file to a specific location on a virtual machine. In Post-Build Actions, click on Send Build Artifacts over FTP. Select the FTP server name configured in Jenkins. Configure source files and the remove prefix accordingly for deployment of an Azure Web App. Tick verbose output in console. Click on Build Now and see what happens behind the scene. Go to the Kudu console, click on Debug Console, and go to PowerShell. Go to site www-root web apps. Check whether the WAR file has been copied. Visit the Azure Web App URL in the browser with the context of an application.
Now we have an application deployed on Azure Web Apps. It's important to note that the FTP username has to be with the domain. In our case, it can be sample9888/m1253966. Using the username without the web app name won't work. All these different ways of deployment to AWS IaaS, AWS PaaS, Microsoft Azure PaaS, and Docker Container can be used in the final end-to-end automation. Nice! So this final video showed us how to deploy application in Microsoft Azure. So here we are at the end of this section. In this section, we saw how to deploy the application on remote server, in Docker, in AWS, and in Microsoft Azure. In the upcoming section, we will deal with monitoring infrastructure and applications.
Hi viewers, welcome to the first video of this section, monitoring infrastructure and applications. The main purpose of this section is to describe the need of continuous monitoring and its significance in the end-to-end automation process in the context of DevOps culture development. This section covers different aspects of monitoring, such as cloud resources, application server, and application monitoring to increase services, and application availability. Now we move on to the first video of this section, getting started, monitoring. In this video, you will learn about the importance of monitoring, and you will also learn to notify the respective stakeholders for corrective measures. Let's begin with a simple definition of monitoring, and then we will gradually move towards cloud monitoring. The main thing here is about observing progress of some operation or activities performed, and to make sure that end goal or performance objectives are achieved as desired. It ends its area from observing to analysis, from analysis to detection, and from detection to notifications to respective stakeholders for corrective measures. In general, what kind of monitoring do we need in traditional environment? Just consider a component of cloud service model to understand it in a better perspective. In cloud computing, there are three service models. The first one is infrastructure as a service, next one is platform as a service, and the last one is software as a service. To get a clue from it, it is extremely important to monitor infrastructure as well as platform running web application. Let's take a case of AWS EC2 instance that can be used to deploy the sample Spring application, Pet Clinic. You need to ensure that instance is running properly, Tomcat server is performing well, memory consumption, CPU utilization, and so on. The next level is to monitor application itself. Application security monitoring and performance monitoring is extremely critical to make an application highly available and avoid failures. Monitoring strategy has to be end-to-end to be effective. It should be in place at the time of design and not the afterthought. Prevention is always better than cure, and it avoids cost implications. Roll back to last successful builds and last-minute headaches. Nice! Now you've learnt the basics of monitoring. Its importance, and you've also learnt to notify the corrective measures to respective stakeholders. In the next video, we will learn about monitoring tools and techniques. Hello, welcome again to the second video of this section. Overview of monitoring tools and techniques. In the previous video, we learnt the basics and uses of monitoring. In this video, we're going to see about the monitoring techniques Nagios monitoring tool, Azure Web Apps monitoring, and AWS Elastic Beanstalk. Let's begin with Nagios. What is Nagios? Nagios Core is an open source application written in C and PHP to monitor services, networks, and infrastructure. Let us get to know more about some of the important features of Nagios. First feature is it supports monitoring of host resources. Secondly, it supports auto-discovery, which means it automatically discovers host or network devices Xenos is connected to. Yeah, it also supports IP SLA's report. Then it also supports user-defined groups to organized host or devices Xenos monitors. It supports secure remote monitoring through SSH or SSL encrypted tunnels. It supports SNMP statistics and provides reports on syslogs. More than all these, its main feature is that it is a simple and easy to use web interface for analyzing current network status, and so on. Nagios XL uses Nagios Core as the backend and provides an extended interface for monitoring resources. Nagios XL is supported in CentOS and Red Hat. So let's start with Nagios. First, go to the web address that you see on the screen and download VMware 64-bit virtual machine so we can use the image in VMware Workstation. And then, open the OVF in the VMware Workstation and name it and the start import Nagios OVF. Import the Nagios OVF file. It will take some time. Just relax till completion of the process. Cool, the file has been imported. Once importing process is completed, click on the power on this virtual machine. Once the virtual machine is ready, log in as root with password Nagios-. Don't forget to note the URL to access Nagios dashboard. Then open the Nagios URL from the browser and click on the Access Nagios. Note the username and password with other details and then select the time zone and click on Install. Once the installation is complete, click on the Login to Nagios Excel. Hooray! We've installed Nagios. Our next step will be to configure Nagios to monitor resources from cloud platforms. Now, to monitor cloud resources with Nagios, we will create a simple scenario to monitor an AWS instance using Nagios. Log into Nagios dashboard using admin credentials and accept the license agreement. On the screen, you will see the Nagios dashboard, and we can configure our AWS instance to monitor with it. From the navigation menu, go to Configure section for Auto Discovery Job. Now there are different options also available to monitor in the Configure section. We can also configure monitoring using configuration wizards. We have created AWS Linux instance, and we would like to monitor it using Nagios. First select a Linux server. After selecting Linux server, get the IP address of AWS instance and input it here. Select the Linux distribution as Other. Then, click on Next. Post that you have to verify the IP address in the next step. You have to provide host name for the EC2 instance. Then, configure the basic parameters for monitoring and click Next. After clicking Next, you have to configure notification settings, and then configure the host groups. Click Apply to finish the configuration. Within a few minutes, monitoring of EC2 instance will start. Then, click on the EC2 instance in Nagios dashboard. It is showing the status as down. Verify the host status in detail and then click on the Ping this host. Then, we will get the packet loss message. Go to AWS Management Console and change in the inbound rules of security group assigned to EC2 instance to all ICMP traffic and verify Ping this host again, and we can see ping requests are successful. You then have to verify the host availability. Click on the graph and get details on host data and service data. Verify the Nagios dashboard and check if all 3 configured instances are up. You again have to verify the host status detail. From the Incident Management section, click on the latest alerts to get details on the latest notifications or alerts. Click on the EC2 and get all the notifications for EC2 instance. We can verify service status from Nagios dashboard. We can also verify host group status from the Nagios dashboard. In the Graph section, click on Graph Explorer to get graphical details on top alerts produced in the last 24 hours. Nice! In this video, we've successfully learned how the Nagios monitoring tool works. In the next video, you will learn about monitoring AWS Elastic Beanstalk. Welcome back, viewer. You are now watching this section's third video, monitoring AWS Elastic Beanstalk. In the previous video, we learned about the working and functions of Nagios monitoring tool. In this video, you will be learning to deploy Pet Clinic application into AWS Elastic Beanstalk. Let us begin with monitoring AWS Elastic Beanstalk. We have deployed Pet Clinic application into AWS Elastic Beanstalk, as well with the use of Jenkins plugin. In AWS Elastic Beanstalk, health status of an environment is determined by grey, green, yellow, and red colors. The grey color indicates that environment is in the process of updating, while green indicates successful health check status in recent times, whereas yellow indicates that environment has failure of one or more health checks, and red indicates that environment has failure of 3 or more health checks. The health status is based on the response of an application running in the environments. We get basic details such as health, as well as configuration of instances, on the environment dashboard in AWS Elastic Beanstalk. Click on Monitoring for extensive monitoring details in form of CPU utilization and health of an application. We can change time range to get more details on monitoring. For more information on monitoring AWS Elastic Beanstalk, visit the web address which you see on your screen. Great! In this video, we have learnt about AWS Elastic Beanstalk and also learnt to deploy Pet Clinic application into AWS Elastic Beanstalk. In the next video, we will be going through monitoring Microsoft Azure Web App Service. Hello, you are watching the final video of this section, monitoring Microsoft Azure Web App Service. In the last video, we have learned about the AWS Elastic Beanstalk. Now, we're going to learn how to deploy Pet Clinic and various applications in the Azure Web Apps. In Section 6, Cloud Provisioning and Configuration Management, we deployed Pet Clinic application in the Azure Web Apps. Once deployment is successful, monitoring web app is an essential activity, and Azure Portal itself provides many ways to monitor it. In Azure Web App, find Monitoring section below Application Details. Click on Edit to change the time range and chart type. Verify the updated graph with more details based on selection. In Application, go to Settings and navigate to Features section. Click on Diagnostics Logs. Here we can select Application Logging File System, Level, Application Logging Blob, Web Server Logging, Detailed Error Messages, and Failed Request Tracing. In Application, go to Settings and navigate to Support and Troubleshooting section. Click on Troubleshoot, Verify Resource Health. There are common solutions available here in case common problems such as 5xx errors. In case application is not accessible, we can restart the application or also do Advanced Application Restart. We can also verify activities performed on an application by filtering Audit Logs from Settings. To automatically fix the issue in Azure Web App, go to Settings and navigate to Support and Troubleshooting section. Click on Mitigate. Select the web app and enable Auto Heal. Here we can configure settings to recover from application issues. We can configure max requests per specific interval. Status code related monitoring. For example, when 5xx errors occur multiple times, add details to the rule. Verify newly added details of the rule. Once everything is configured, click on Action. Here we can configure actions on the specific situation we had configured earlier. We can set Recycle to auto-recover from the issues. Now click on the Update button to set the rules for your web app. You'll see a message on your screen. Go to KUDU console by visiting this site. Click on Debug Console. From drop-down menu, select CMD. Click on Log Files. Go to Detailed Errors folder and verify what kind of errors have occurred. We can also get detailed error logs from FREB logs in the portal itself. Once you open the error page in browser, and we will get more details about the error. This is the detailed error. Now go to HTTP and click on raw logs. Open log files to monitor all logs related to HTTP. Catalina logs are also available, and we can get all details about Tomcat server and execution in it. In Azure Web App, go to Application Blade and you will see the development tools. In Development Tools section, we get the feature to test the performance of an application. We need to have VSTS account for this feature. Click on New. Configure test using test type, URL, user load. It will take around 15 minutes to acquire resources. The performance test is over. Now we will verify the details in Azure Portal. Also verify the request failures. Now go to Monitoring section of the web app and check the recent results based on customized parameters. Here there are 2 HTTP server errors and 222 requests. Visual Studio Application Insights is in preview version, and it has a capacity to detect and diagnose issues in web apps and services. Click on Browse in Azure Portal and select Application Insights. Select the application which we have created and enable Application Insights to start collecting telemetry. Click on Start Monitoring. Wait until installation is completed. Verify the successful installation in Portal. In Application Insights, we can also monitor Application Map. In Application Insights, we can configure web tests, check availability of an application from different locations. We can configure availability tests from different regions to verify whether it is available or not. Configure regions based on priority. Now create a web test, and within some time we will get results on Azure Portal. Monitoring web application and Tomcat server with New Relic. New Relic is software as a service in the context of cloud service models. New Relic monitors applications in real time, and that also in any environments such as on-premise or in cloud. We can install New Relic in the application server's root directory, and within minutes it starts providing monitoring and it reflects in the New Relic portal. It allows free trial. New Relic supports monitoring for web applications developed in Java, .NET, PHP, Python, Node.js, Ruby, and so on. First, you create an account in New Relic. New Relic has Java installer for JBoss, Tomcat, Jetty, and Glassfish. And log in to New Relic. Go to Account Settings and download the agent for the specific platform. In our case, we will install a Java agent. In the downloaded zip file, there will be 2 important files that are needed for monitoring. newrelic.jar, that contains agent class files, and newrelic.yml to configure license details that will be available on New Relic dashboard, even for a free trial. Extract the files from the zip folder and put the directory into Tomcat installation directory. After that, open newrelic.yml in Notepad and find the placeholder for license key and replace it with actual license key. It will be in common and default _settings as seen on screen. Run Tomcat. Once Tomcat is up and running, open a command prompt and go to the directory of New Relic in the Tomcat root directory. Post that you have to execute java-jar newrelic.jar install in the command prompt. We will now monitor an application that is deployed on a local environment in Tomcat 7. We can do similar installation and monitoring for virtual machine available in cloud or virtualized environment. Once the installation is successful, you have to restart the Tomcat server. Verify the new relic directory under Tomcat installation directory. Now, new log folder will be created. Open new relic_agent-log file in Notepad. Verify the reporting to line. Copy the reporting URL and open it in browser, and you can observe the overview section with graphs. After that, click on the applications link to get list of applications. The service maps provide view of relationships between different components. In the monitoring section on the left sidebar, click on the databases to get details of top database operations based on the time. Click on JVMs to get details on the JVM and Tomcat. Verify the Apache Tomcat section for details related to memory, threads, and HTTP sessions. In the same page, garbage collection and class count related details are also available. Errors section will display graph of errors if you have requested it. This is just a simple overview of New Relic for our Pets Clinic application deployed on premise. So until now we have covered overview of installation and configuration of Nagios, monitoring of AWS Elastic Beanstalk environment, monitoring of Azure Web Apps, and application monitoring with New Relic. Monitoring itself is a huge topic, and to cover things in detail is out of scope of this book, so we've only covered some portion to give a glimpse of monitoring of resources. In this video, we have learnt about Azure Web Apps application monitoring and Java Web Application monitoring with New Relic, and learnt to deploy Pets Clinic. In this section, we have seen a quick overview of instance monitoring with Nagios, basic monitoring with AWS Elastic Beanstalk, Azure Web Apps monitoring, Java Web Application monitoring with New Relic, and deploying a Pets Clinic application. In the next section, we will be learning about orchestrating application deployment. Hi, and welcome to Section 9, Orchestrating Application Deployment. In this section, we will be learning how to create build jobs for end-to-end automation. We will also learn about configuring SSH authentication using a key. Now we move on to the first video of this section that deals with creating build jobs for end-to-end automation. In this video, we're going to take a look at the basic steps to create build jobs for end-to-end automation. Creating build jobs for end-to-end automation. Before we configure end-to-end automation for build job execution, let's understand it graphically. We will configure it using upstream and downstream job configuration in the case of build pipeline plugin, while in the case of the Jenkins 2.0 pipeline, we will use a script. Configuration management depends on the environment we use for deployment. We have covered some deployment environments in this video course. Pets Clinic Spring Application Deployment on a Tomcat server, Pets Clinic Spring Application Deployment on a Tomcat server on Amazon EC2 IaaS, Pets Clinic Spring Application Deployment on a Tomcat server on a Microsoft Azure Virtual Machine IaaS, Pets Clinic Spring Application Deployment on a Tomcat server in a Docker image container, Pets Clinic Spring Application Deployment on a Tomcat server on Amazon Elastic Beanstalk PaaS, Pets Clinic Spring Application Deployment on a Tomcat server in Microsoft Azure Web Apps PaaS. Based on the deployment environment, we need configuration management. In IaaS, we need to install a runtime environment, while in the case of PaaS and Docker containers, we only need minor modifications of the addition of a file or similar types of smaller changes. Considering the deployment environment, we need to introduce build jobs for end-to-end automation. In the case of the Pets Clinic Spring Application Deployment on a Tomcat server on Amazon EC2 IaaS, we need this flow. Let's try to implement previous steps in Jenkins to achieve end-to-end automation that includes the previously mentioned steps. Let's visit the Jenkins dashboard. Click on Manage Jenkins. We can see that a new version of Jenkins is available. Click on or upgrade automatically to update the application. It will start installing jenkins.war. Once installation is successful, restart Jenkins from the terminal. Here we have come to the end of this video. We've understood how to create built-in jobs for end-to-end automation. In the next video, we will learn about how to configure SSH authentication using a key. Hi, and welcome to the next video of the last section, configuring SSH authentication using a key. In the previous video, we got to know about creating build jobs for end-to-end automation. In this video, we're going to take a look at how to configure SSH authentication using a key. Before starting with end-to-end automation and orchestration, we need to configure SSH authentication using a key. The objective behind it is to allow the Jenkins VM to connect to the Chef workstation. Then, we can issue SSH commands from the Jenkins dashboard on the Chef workstation VM to create an instance in AWS or Azure Cloud and install a runtime environment on it to deploy the Pets Clinic application. If we try to access the SSH Chef workstation from Jenkins, it won't work as we still need to configure password-less configuration for security. Let's configure virtual machine where Jenkins is installed to access virtual machine where Chef workstation is installed. Open a terminal in Jenkins. Use SSH-keygen to create a new key. Verify the newly generated key on the local file system. Copy the key to the remote host using SSH-copy-ID. Now try to access the Chef workstation using the Jenkins build job. If it fails, then try to access it from the Jenkins VM using a terminal. If you get the agent admitted failure to sign in using key message, then use SSH-add to fix the issue. Now, our SSH connection is successful using not a password but a key. Let's try to create an instance in AWS using the Jenkins build job and Chef workstation. Add a build step, select execute shell, and add paste the command mentioned here. We've already discussed knife EC2 commands in section 6, Cloud Provisioning and Configuration Management with Chef. Click on Save. Click on the Build Now link to execute the build job. Go to Console Output to check the progress. AWS instance creation has started. Verify it in the AWS Management Console. Before its execution can go further, check whether the AWS security group has an entry for SSH access. Once SSH access is available, it will start Chef client installations. In our case, it will start downloading the Chef client and installing it on the AWS instance. Verify the Chef installation process on the console. Once the Chef client is installed on the AWS instance, it will start its first Chef client execution. Observe the run list and synchronizing cookbooks. It will converge and start installing packages. Verify the package installations. It will also display conf.xml, where port-related details can be verified based on the configuration. Once the package installation is finished, it will start service management. Now, the Chef client execution has finished, and it will display related information for the AWS instance we created. Check the AWS Management Console for the successful status. We've used a different agent node for some build jobs. To keep it ready, make it active. Go to the Jenkins dashboard and click on Manage Jenkins. Navigate to Manage Nodes and verify the status of both the master and agent. Verify hosted Chef for registered nodes. Now, we have all the resources ready to configure the build pipeline. In this video, we've configured SSH authentication using a key. In the next video, we will learn about configuring the build pipeline for build job orchestration. Hello, and welcome to the third video of the last section, configuring the build pipeline for build job orchestration. In the previous video, we learned about configuring SSH authentication using a key. In this video, you're going to learn how to integrate all the work in a way that continuous integration, cloud provisioning, configuration management, and continuous delivery is orchestrated in a sequence. Let's begin. Firstly, in the Jenkins dashboard, go to petclinic-build-pipeline-view. Click on Configure to view and modify settings. Now, in Build New Title, type First Pet Clinic Build Pipeline. Select Initial Job as Pet Clinic Compile. Once we click on OK, changes are saved and we see the configuration as shown here. It is the output of the upstream and downstream job configuration. To create complete build, we need to configure post-build actions of each build job that we want to execute in specific sequence. We have different build job for continuous integration, configuration management, and continuous delivery, so we will configure them as upstream and downstream jobs to make pipeline. Let's look at each build job configuration step by step. Click on pet clinic-compile and then configure. Go to post-build actions. In the build other projects section, we configure the build to be executed after pet clinic-compile has been completed successfully. Save it and verify downstream projects on the Jenkins dashboard. Click on pet clinic test configure. Go to post build actions. In build other projects, we configure the build to be executed after pet clinic-test has been completed successfully. Configure the archive artifacts so we can copy it for deployment. Verify upstream and downstream projects for the pet clinic-test build job in the Jenkins dashboard. Execute the build independently to check whether the artifact or WAR file is archived. Verify the archived artifact in the Jenkins home directory. Click .jenkins, Workspace, Pet Clinic Test, Target. You can see here that Pet Clinic WAR is present. At this stage, the build pipeline will look like this. Click on pet-clinic-cloud provisioning and then configure. Go to post build actions. In the build other projects section, we configure the build to be executed after pet clinic-cloud provisioning has been completed successfully. Projects to build would be pet clinic deploy. Click apply and then save. Verify upstream and downstream projects for the pet clinic-cloud provisioning build job in the Jenkins dashboard. Click on pet clinic-deploy, configure. Our WAR file was ready in the pet-clinic-test build job, so let's copy it to a common location and configure it as a build step. Click on add build step. Click on artifacts from other projects. Give the name as pet-clinic-test. Select stable build only. Artifacts to copy: */target pet-clinic.war. Target directory /home/user. Click apply and then save. Configure the build step to copy the artifact and verify it by executing the build independently. Once the artifact copy operation is verified, configure the build job so we can deploy it as a manual operation. We will create a job with the string parameter of a newly created instance's domain name or IP address. Click on Configure. Click on This project is parameterized. Add string parameter named AWS-DNS. Click Apply and then Save. Go to the Pet Clinic-Cloud Provisioning build job and check whether we have added Build Other Projects for the Pet Clinic-Deploy build job. Once you've verified this, let's move to executing the build pipeline. Once our artifact is ready to deploy, we need to perform these steps. First one is to convert SSH to AWS instance. Next, you need to copy WAR file into destination web apps folder of Cloud Resources Tomcat directory. And finally, you need to restart the Tomcat instance and verify the application. Let's configure the build job to execute deployment of WAR file in AWS instance by executing the command which you see on the screen. Once all build jobs have been verified as running individually, run the build pipeline. After that, when all 3 build jobs have been executed successfully, we need to manually execute the last build job for deployment because it contains this. Wait for the build job's result. Once the application deployment is successful, we have all the successful build jobs in the build pipeline. Check whether the application is running properly and whether it is configured in Hosted Chef. In order to deploy the Pets Clinic Spring application in Amazon Elastic Beanstalk PaaS, we need to first create environment in Amazon Elastic Beanstalk, then build it using continuous integration. Finally, build it by continuous delivery and continuous deployment. To deploy the Pets-Clinic Spring application in Microsoft Azure Web Apps PaaS, we need to create Azure Web App, then build it using continuous integration, and finally perform continuous delivery and continuous deployment. In Microsoft Azure's case, there is an alternative as well. We can use Visual Studio Team Server and TFS Online for continuous integration, continuous delivery, and continuous deployment. Now to deploy the Pets Clinic Spring application in a Docker container, we need to first build continuous integration. Then you have to create a Docker container and finally perform continuous delivery and continuous deployment. Cool! In this video, you have learned the procedure for configuring the build pipeline to build job orchestration. Awesome! In the next video, you'll be learning about executing the pipeline for application deployment automation. Hi, this is the 4th video of this section, executing the pipeline for application deployment automation. In the previous video, we learnt about configuring the build pipeline for build job orchestration. In this video, we are going to learn how to provide features to orchestrate end-to-end automation for application deployment. The pipeline feature in Jenkins 2.0 also provides features to orchestrate end-to-end automation for application deployment. I will provide the script which achieves checkout, continuous integration, cloud provisioning, and configuration management. First, create a new item in the Jenkins dashboard and select Pipeline. Click on Pipeline. OK. In the Pipeline section, now write the script and make necessary changes. Enter this script, Node Master. Make stage checkout with your valid key ID and your key password. Once the script is modified and saved in the build job, click on the Build Now link and verify the execution. In the end, check the DSL reference and use the script to perform all the operations. Awesome! In this video, you have learnt to provide features to orchestrate end-to-end automation for deployment of application. In the next video, you will learn about DevOps dashboards. Hello viewer, you are watching the final video of this section. Hi Gia, a DevOps dashboard. In the previous video, we learned how to execute the pipeline for application deployment automation. In this video, you will be taught to provide a unified, configurable, and easy to use DevOps dashboard for an end-to-end application delivery pipeline using Hygeia. So why is DevOps used? DevOps is used to provide a view of all the tools in a single dashboard. Hygeia is an open source initiative to provide a unified, configurable, and easy to use DevOps dashboard for an end-to-end application delivery pipeline. To install Hygeia in your computer, visit the site. Once you finish installing and configuring successfully, you have to create a DevOps dashboard, which should look like this. We can then configure SVN, Git, Sonar, Jenkins, and IBM Urban Code Deploy in a Hygeia dashboard. Hooray, you did it! So in this video, you learned to use the Hygeia dashboard to provide a unified, configurable, and easy to use DevOps dashboard for an end-to-end application delivery pipeline.